Hello everybody, and welcome to this week's slightly different Sleepy Sunday stream. So, long story short, I couldn't really think of a game I really wanted to play today on the stream. And as some of you might be aware, there have been, how to put this, events going on recently with Unity and in the game development community. Now, I use Unity. I used it for Solos 128 and I'm using it for CRT7, my upcoming game. However, with everything that's been going on, I feel like maybe it's a good idea to explore other engines, not just for me and my future games, but also because I lecture about development and game design, and I wanted to investigate other engines for that as well. Hey, Port Ponky, thanks for joining us. Now, there are two engines I'm kind of looking at. One of them is obviously Godot, and I've done a bit of the Godot tutorial stuff before, but what I want to do before I decide which engine I might look at in the future is figure out a bit about how different ones work and which ones will fit my workflow and my art style. And as I say, I've done a bit of Godot in the past even, and I hopefully will do some in the future, and I thought it was about time I got my bum in gear and started looking at Godot in 3D, because that's how I tend to make my games. So, today, I'm going to be slowly, hopefully going through your first 3D game tutorial in Godot, pretty much from scratch, to see how it goes. I will say as well, sorry to Port Ponky in the chat, I'm not going to be using GD script, because I tried it and I strongly disliked it. So I've set it up in such a way I can use C#, which is a language I prefer and I have more knowledge of, so it will hopefully smooth the transition a little bit. Apparently, this is what we're going to end up with if we manage to do the whole tutorial today. A little 3D scene where we can jump up and down and land on these blue things, which I think they're calling creeps. So, I guess let's get going. I've already downloaded the assets and imported them. The assets come for Godot 3, so you need to just convert them up to Godot 4, which is what I'm using. Hopefully they'll work. I guess we'll find out as we go. What are we going to do today? Learning outcomes, lovely. Puts me right back in my academic day job. We're going to work with 3D coordinates. We're going to use kinematic bodies to move 3D characters and do collisions. We're going to use physics layers and groups to detect interactions. Yeah, that's all classic. Code basic procedural gameplay by instancing monsters at regular time intervals. Again, pretty classic. Design a movement animation and change its speed at runtime, and draw a user interface on a 3D game. So that all sounds pretty understandable if you broadly know what's going on with coding or you've used games engines before. Procedural gameplay's a pretty grand way of putting we're just going to spawn enemies, but sure. So, I guess what I'm going to do is probably move the instructions off this screen over to a screen over there. See if I can get that actually where I want it. Get the chat up there. Perfect. And I'm going to go to the first thing, setting up the game area. I guess I should open Godot. Cool. So, as I say, I've already downloaded the assets and it comes with a kind of a project to start with. But I'm going to be talking through this as I go, as sort of a Unity native, because that's what I've developed in for the last X number of years. So this is a bit like the Unity Hub launcher thing. Why is this 4.0.3? Because I've already done some of the tutorial stuff and it's all set up to work and I didn't want to upgrade it until I finished the tutorial. I'll move up to 4.1 at some point, but it's 4.0 stable, so shrug. By the time I've done the tutorial stuff, we'll probably be at 4.2 anyway. So yeah, this is a bit like the Unity hub launcher. It's where all your projects live. The slight difference with Godot is it's all kind of in a single executable you run, rather than having the multiple different stuff spread about. Alright. So this is our development environment, I guess. This is what I'm trying to remember what I learned from the previous tutorials. So we've got our screen in here. This is sort of our game view. Depending whether you set up as a 2D or a 3D scene, you can switch between. This is where your scripts live if you're doing GD scripts, but we won't be living in here today. And then the other stuff's relatively understandable if you come from Unity. This is your scene hierarchy equivalent. This is your resource stuff. And this is your inspector over here. So it's a pretty standard layout if you've used stuff like Unity before. The 3D scene, I think, is right-handed instead of left-handed, but also I never paid enough attention to that to really know, so. Okay, how are we starting? Setting up the game area. This first part, we're going to set up the game area. Let's get started by importing the start assets and setting up the game scene. We've done that stuff. We've imported it already. Set up the play area. So, yes, one of the things about Godot that's very different to Unity is there's no concept of scenes as far as I'm aware. Nodes are both game objects and scenes, which took a while for me to get my head around. What it means is you can basically instance any part of the hierarchy, and that's so your scenes are effectively defined as a root node with other stuff under it. Okay, we are going to create our main scene with a plain node at its root. In the scene dock, click the Add Child Node button represented by a plus icon. Double click on Node. So this is the hierarchy of all the stuff you can add. See, I think everything you can add to the scene is eventually parented to Node. But again, I'm not an expert on Godot, so take anything they say with a little bit of a pinch of salt. So we're using a plain node, so we double click that, we add it into our scene. It's suggesting that we rename it to main. An alternate method, F2, that's fine. Save the scene as main.tscn. This is the one thing I will say that I really don't like about Godot, is I don't like it not using the native file managers. Like, I get why, because they want to port it everywhere, but I don't like it when people overwrite the default file stuff, because it messes up all your shortcuts and they're normally not as fully functioned. But it is a small price to pay for some of the other stuff. Just going to give ourselves a folder there to put these in. Alrighty. We're going to start by adding a floor that prevents the characters from falling. To create static colliders like the floor, walls, or ceilings, you can use static body 3D nodes. They require collision shape 3D child nodes. To define the collision area, the main node being selected, add a static 3D node and then a collision shape 3D node. It's just a type node, so it's the root object of everything else pop bonky. That's what the tutorial's telling me to do. Okay, so let's add a child node. They wanted a static body. I do like how searchable this is. It's really, really nice. Static body 3D, and it's nice that it tells you what all the nodes are at the bottom as well. Physics body for 3D physics, which is static on moves only. Script. Hello, Scotty. That is a joke that I will. You are not too late to wait for Godot. Alright, we'll put a static body 2D in. we're going to rename to ground. And we're going to give a collision shape. Shape 3D as a child of that. I'm just checking the tutorial. Yeah, sometimes the tutorial is a bit unclear about the scene structure it wants, but it does always give images, which is normally quite nice. Alright. A warning sign next to the collision 3D appears because we haven't defined its shape. If you click on the icon, a pop-up appears to give you more info. Yeah, there we go. A shape must be provided for collision shape 3D to function. Please create a shape resource for it. Cool. To create a shape, select the collision shape 3D node, head to the inspector, click on this empty field next to the shape property, create a new box shape 3D. Oop. Okay, and then we can see in the scene here, if I can remember how you actually move around this, which I remember being a bit odd for if you're used to Unity's movement. But we've got kind of these lines will be the extent of the collider, I suspect. Box shape's perfect for flat grounds and walls. Its thickness makes it reliable to block even fast-moving objects. The box's wireframe appears with 3 orange dots. So I guess that's for doing whoop whoop, whoop whoop, whoop whoop. And we can also precisely set the size in the inspector. Can we? Interesting. Set its size. Can we? That's interesting. Oh, thank you, Port Ponky. Yes, this was the other issue I had with Godot. It's not a problem with Godot, but it's a problem with how I'm used to it. Sometimes it actually embeds stuff inside the inspector in this weird hierarchy, and I always kind of don't realize that, because in Unity this would be broken out into another collapse. So it's just a slightly different workflow that my head's not used to yet. Okay. Set its size to 60 on the x-axis, 2 on the y-axis, 60 on the z-axis. Custom solver bias. Okay, well, we're not going to fiddle with that yet. To be fair, the tutorial does say click on the box shape 3D to expand. I just skipped that bit. But the tutorials are actually really good. I'm not going to besmirch the tutorials. It's just I come with a lot of pre-built-in expectations because of having used a different environment for so long. Okay, collision shapes are invisible. We need to add a visual flaw that goes along with it, obviously. Select the ground node, and add a mesh instance 3D to it as a child. Okay. Node that instances mesh into a scenario. Yeah, that makes sense. In the inspector, click on the field next to mesh. Create a box mesh resource to create a visible box. Ooh, hello. This is one of the questions I wanted to answer. How many primitives does Godot actually come built in? Because I tend to build my games out of primitives in engines. And that is a nice set. Very nice. Boxes, capsules, cylinders, planes, quads. Planes are just normally quads with more... basically more vertices in. Prisms, spheres, text mesh. Interesting. Torus mesh. Also interesting. Tube trail mesh. Ribbon trail mesh. And point mesh. Those ones at the bottom are very interesting. Huh. Anyway, we just want a box mesh for now. Oh, there it is. So tiny. If I double click on this, will it zoom in? Yeah. Oh, that'd be interesting if you can make your own. I mean, it's already got more than Unity's got built in, so that's always nice. Yep. So we've created a visible box. And then we want to, I guess... Nope. Oh, that's interesting. So that changes it, but clicking there or there. Nope, just there opens it. Okay. So we want 60 to 60 again. And now we've got a blinding white floor. I wish I could remember how to move round. Move round in the end in this better. Oh well. I will say, Port Ponky in the chat has been using Godot for a long time, so he'll know answers to this better than me, and he's also quite a fan of it as an engine. I am still on the fence, which is part of the reason for doing this stream. Okay, we should see a wide grey slab that covers the grid. Yeah. We're going to move the ground down so that we can see the floor grid. Select the ground node. Hold the control key to turn on grid snapping. Okay. And click and drag down the y-axis. Oh, that's quite nice. You can see in the bottom left corner there. Also tells me how much I'm translating it. That's very nice, actually. What units are we on? Move the ground down 1 meter. So it is in units. Okay, cool. If you can't see the 3D object manipulator, ensure the select. It's up here. Oh yes. So it has this thing that I actually genuinely hate, which are these Omni selectors, where they show rotate, scale, and translate all in one. I think they're really noisy, so I'd already moved over to the separate ones, which I prefer. But you know, you've got the options, so who cares? If there's one I don't like, I'll just change. Okay. Moving the ground node down moves both the children along with it. Yeah, so now we can see, we click here, we can see this very faint blue outline. They've been moved together in an orange outline. Oh, I see. So it looks like a blue outline for invisible colliders, orange outline for visible objects. Nice. We can just check that's done what it should have done. There we go. Transform. Yeah, -1 meter. Okay, cool. Let's add a directional light so our scene isn't all grey. Select the main node and add a child node directional light 3D. Interesting. This is the other thing I want to discover is the type of lighting that Godot has. So directional lights, if you don't know, they're kind of parallel, very distant lights. So stuff like the sunlight, all the lights come from one direction. Spotlights are like a car headlight, very directional. Omni lights, omni lights are what's often called a point light. So a single light source that then radiates in kind of 360 degrees, I suspect. But I guess we'll find out. It wants us to do a directional light, so let's do a directional light. Which it spawned at 0, 0. I assume if I look at the transform. Yeah, so it's spawned at the origin, so it looks weird because our rotation, I'm not sure which direction 0, 0, 0 would be. We need to move and rotate the directional light 3D node, move it up by clicking and dragging. Drag on the red arc to rotate it until the ground's lit. So let's boop, and then we'll switch to this one. Oh, it's got an arrow showing its direction. That's very helpful. Oh god, I am not figuring out how to move around in this environment well. So you can see there, that arrow changes as we rotate our directional light. Let's give it put it on a jaunty angle. We're probably just going to move that a bit out of the way, because normally with directional lights you don't get fall off and things like that, so it can be anywhere you like away from here. In the inspector, turn on shadow enabled by clicking on the checkbox. Boop. Yeah, we've got kind of classic lighting stuff where we've got color, so you'd be like, I want it to be colored magenta. Oh, you can do it in HSV as well. Or RAW. Oh, I don't know. Huh. Okay, I have no idea what colour system that is. But, as someone who's rather obsessed with Bloom, that looks like how we put... Oh, we overlight the scene to force bloom. So quite often when you're doing kind of bloom stuff, you use a high definition lighting system where you can put more energy into the lighting than would be visible, and that's what makes stuff glow. And that does look very much like that's what that's doing. Colour me intrigued. Yeah, see, it's going above 255. Well, that's the thing. It goes between 0 and 1, but you can go above it. So that's exciting. Whereas we can't really technically... It doesn't seem like we can go above it in here properly. So I guess raw... Yeah. Anyway. Tutorial stuff, rather than me getting distracted by wanting to put bloom on everything. So, that is the end of the first page. We have set up our scene. I am going to give it a slightly orangey light, though. Which means none of that. I'll have to bring that down a bit to make it orangey. Down a bit as well. I'm feeling autumnal, you know, with my lighting. Okay. Now, what we could do is we could hit this button up here. And see what happens when we run the project. We need to select a current scene. Cool. And we see nothing, probably, I'd assume, because we haven't got a camera in yet. So it doesn't know where the player's viewpoint is. Oh, does this let us do orthographic views? Oh, that's really nice. That's really nice. Like that little tool thing. Kudos. Right, anyway. So as I say, I'm learning this as I go. So we've set up the playable area. Let's move to the next step on the tutorial. Player scene and input actions. In the next two lessons, we'll design the player scene, register custom input, and code player movement. By the end, you'll have a playable character that moves in 8 directions. Create a new scene by going to the scene menu in the top left and clicking new scene. So this is where I really need to change how I think about stuff coming from Unity. So the tutorials, they always do stuff like, they say make this new scene, and you'll go off and make like a player scene where you make the player character and you can move them around. But because there's no differentiation between scenes and prefabs in Godot, it confuses me. Because what happens is you can make this player input scene an entirely separate scene, but then you can add it as a child of this other scene, because scenes and prefabs are the same thing in Godot. So it's really nice in some ways for breaking apart the different bits of functionality and making them all quite nicely distinct from each other and non-overlapping and non-interfering, but it does make my head go a bit confused because I'm so used to there being a separation. Anyway, you'll see what I mean hopefully as we go. So let's make a new scene. And that takes us back to exactly where we were before, effectively. Create a character body 3D node as the root. So we can just go other node here, character. Specialize 3D physics body node for characters moved by script. Alright. Rename that to player. Character bodies are complementary to the area and rigid bodies used in the 2D game tutorial. Like rigid bodies, they can move and collide with the environment, but instead of being controlled by the physics engine, you dictate their movement. We'll see how to use the node's unique features as we code the jump and squash mechanics. Fine. For now, we're going to create a basic rig for our character's 3D model. This will allow us to rotate the model later via code while it plays animation. add a node 3D node as the child of player and name it to pivot. Okay. So a node 3D is just a 3D game object, that exists in a 3D space, whereas a node 2D is a 2D game object that exists in 2D space. So 2Ds have Z index, whereas node 3Ds will have Z position, which is the main difference. Boop. And Z, which I am very happy with in Godot, depending how you set it up, can still be kind of in and out of the scene. But again, it depends how you lay stuff out. I'm very used to XY being ground plane and Z being up. So I think technically this is a different way around because it's using it's using the XZ ground plane, which no, I refuse to accept that. But that's just how you set up your coordinate axis when you're starting. Okay, and got distracted. It says to name that to pivot. Then in the file system doc, expand the art folder. Okay. This is the stuff that came with the tutorial. Drag and drop player.glub into pivot. Okay. Oh, well, hello then. That'll be our character model then. Interesting. This should instantiate the model as a child of pivot. Oh, no, I've done that wrong. So let's try that again. Ah, that means under. That means child of. There we go. So this is the same as in Unity. You can instantiate stuff just by dragging it in. So it's instantiated the model as a child of pivot. You can rename it to character. Fine. The GLB file contains 3D scenes data based on the open source GLTF2 specification. They're a modern and powerful alternative to FBX. Blah, 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 blah. You can make them in Blender 3D. Fine. Punky says you can drag nodes around in the tree. Yeah, I expected you'd be able to. I just am trying to follow this, properly. But yeah, cool. Good to know. As with all kinds of physics nodes, we need a collision shape for our character to collide with the environment. Select player node again. And add collision shape 3D. Cool. Then we go to a shape property. This time it's suggesting a sphere shape. The wireframe appears below the character. Oh, I think it is there. That's it poking out. It'll be the shape the physics engine uses to collide with the environment, so we wanted to better fit the 3D model. Shrink it a bit by dragging the orange dot in the viewpoint. My sphere radius is... I think that's the difference between... This tutorial was written for free. They've obviously changed some custom, so I think in free it defaults to importing with a radius of 1. Although to be fair, a radius of 1 looks about right to that for that. But they suggest 0.8, so I'm going to go with 0.8. Knowing that we can always fiddle this later. Then move the shape up so its bottom roughly aligns with the grid's plane. Okay, but we should be able to be like... You toggle the model's visibility by clicking the eye icon. Ah, helpful. Okay. And we can go kind of orthographic to do this. Whoa. Which will make this really easy to line up. Perfect. Well, the transform wouldn't be... Would it be? Oh yes, because that's a radius, not a diameter. Yeah, absolutely. I think they're just saying how to do it visually as well. We can do it that way too. But I'm exploring the engine's capabilities and the development environment's capabilities, and I like the fact I can easily drop into that. Right. Oop. Now we save this scene as player. Oh no, in all of my games I'm incredibly specific about those numbers in an upsettingly obsessive manner. But, you know. Okay, creating input actions. To move the character, we will listen to the player's input, like pressing the arrow keys. In Godot, while we could write all the key bindings in code, absolutely should never do that anyway. There's a system, a powerful system that allows you to assign a label to a set of keys and buttons. This simplifies our scripts, blah, blah, blah. This system is in the input map, the project menu, project settings, input map. Yeah. Godot projects come with some predefined actions designed for user interfaces design, which we could use here, but as we're defining our own to support gamepads. There we go. There's the built-in ones. They're hidden normally. That confused me a lot in the 2D tutorial because I don't think they were necessarily hidden in Godot 3. Yeah, I said that just as your thing popped up there. Poor Ponky. Okay, we're going to name our own actions. Move left, move right, move forward, move back, and jump. To add an action, write its name in the bar at the top and press enter. Yeah, again, this is where I think the input stuff's been really overhauled since 3. 3 doesn't seem to have the filters either. So, improve for the better. Left, right, move forwards, move back, jump. There we go, and now we have a bunch of actions. To bind a key button to an action, click the plus button to its right. Press the left arrow key. Okay. Now this is one thing I will say, so much better than Unity's input system. Unity's input system worked, but you couldn't just press a button and it figured it out. Oh no, they were very strangely named, and you got used to it, but seriously. And we can also then say we also want it to be A, and we can just add as many of this as we like. Now, it's saying I can do this to the left joystick. I can do manual selection. I'm curious, can I do this? I can do that with my joypad. Joypad access 0, left stick left. Perfect. Very nice. If you want controllers to have different input actions, you should use the devices option and additional options. Device 0 corresponds to the first one, etc, etc. Alright, well I guess now we go through, we add them for the others. As you can see, it is super smooth to actually do this. Oh, no. Can't use enter, obviously, to accept that because it will read that as you want to press enter. Space key and Well, I don't know. I don't know. I've not used Unreal's input stuff, and to be fair, Rewired in Unity is the best input thing I've ever seen. It's incredible. Just much better than Godot's as well. But it is obviously an extra thing that people have made. Oh, yeah, that should be A on the controller. Thank you. I just saw it should be the A button. My monkey brain pressed A, but you're right. It should be on this. I do like this, that it specifies it as the bottom gamepad action. So Sony Cross, Xbox A, Nintendo B, because all of the buttons are different on all the controllers, and it is a flipping nightmare. All right. Okay, so we close that. Save this. Yeah, in the next part we'll code and test the player's movement. Fine, next part it is. It's time to code. We're going to use the input actions we created to move the character. Right click the player node and select attach script to add a new script to it. This leads to the other big difference between Unity and Godot. In Unity, you're allowed kind of an arbitrary number of scripts on a node. In Godot, you can only have one script per node. Now, I will say I've seen a bunch of Unity players or Unity developers kind of complaining about this. I never, ever, ever put multiple scripts on a single game object in Unity because it felt wrong to me anyway. Because I would have one script that would define the behavior of that object, and if I wanted more scripts, I'd put them in child nodes more related to what that child node needed to do. So for me, that is not a thing that is going to be a problem, but for some people, with the way they code and structure their environment, it might be a change. But for me, I saw that and just went, meh, that's how I'll do it anyway. But it is something that's worth knowing about if you're going to come across. Okay. What are we doing? We are in the pop-up. Select template. We're saying select template to empty, but when that's unticked, kind of is anyway, but we'll follow it precisely. What's the difference? Empty template suitable for all objects. Yeah, fine, we'll use it. Create. Now it's going to open us this, our Visual Studio, which I've got set up so it can talk to and debug with Godot already. In version 4, there was a bit of a faff to this that I'm not going to go through. I think that's been fixed in later versions, but don't quote me on it. Either way, it was a very simple workaround, and once I'd done that, it just worked in an environment I knew. So, all good. The only other thing I find weird is that everything is a partial class in Godot. Like, it doesn't matter at all, but I always found it a bit strange. Also, that should be a capital P. C# Godot. Naughty, naughty. Let's see if that breaks everything. Yeah, player was a capital in there. Meh. That might indeed break stuff. We'll fix that later if it does. Okay, let's start with the class properties. We're going to define a movement speed, a fall acceleration, and a velocity to move the character. Oh yeah, the partial, it's not a problem. It's just... not what I'm used to. Okay. So, export is the equivalent of serialize in Unity. It's what exposes it to the inspector, as far as I understand. It's not a direct equivalent, but you know. So we're going to define the speed with our getSet structure in C#. So this means that it's visible from other scripts. it has a getter and a setter, or an accessor and a mutator built in, and we're defaulting it to 14. Oh, no, that's wrong, but thank you for trying to guess. Visual Studio. Full acceleration is the next thing it wants. Get set, and we're going to do that to 75. And then we'll have some private stuff. We have a vector free, just like a position or a direction, but in 3 dimensions. Target velocity equals, and we're just setting that to a vector that has 0 in every axis. Oh yeah, thank you for that. I'm going to spell everything wrong because typing while it's being streamed makes everything go a bit wrong. But thank you for that spot. So these are the common properties for a moving body. The target velocity is a 3D vector combining speed and direction. Here we define it as a property because we want to update and reuse its value across frames. Blah, blah, blah. Okay, so now if we save this, and we go back to Godot, this is something that tripped me up, and the tutorial tells you in multiple places to remember that this is a problem. But we go here, and I'm like, well, the script properties aren't visible. Yeah. Well, it says both here, don't forget to rebuild the project so the editor knows about it, and also I think there's somewhere else where it says it on this page. Or a different, it said in multiple places on the 2D page where it was like, for the love of God, rebuild your project. You silly idiot. Because if you go up here and you just hit the build button here, then they should have appeared up there. Oh no, I was just complimenting you, Godot. Have I not saved you? No, you are saved. This is probably my fault. This is probably because that doesn't now, the names don't match. So let us debug me being an idiot. In fact, I'll tell you what we're going to do. We're going to hoik this stuff out. And then we are going to see if we can figure out where that's gone. That's the question. Where does it actually save the... Ha! There it is. So, if I make this capital and tidy this up a little bit for myself, because that script should be in a nice folder called scripts. Now if I build it, will that be happy or will you be upset? Ooh. That's something that's useful, but we don't want to know just yet. Go away. Now, if I put you onto there. Ah, thank you, Pop Ponky. Okay. So, yes, problem solved. That's fixed. This is appearing correctly, and our stuff is appearing up here. What I was trying to show you before I messed it all up is if we were to put another export in here, and we just save that and go back, it won't appear up here. But the second we hit build, let it build again, then it appears up here. The export to the node, not the script, if it's attached to the node. Okay, good to know. I didn't really even realize I was in that, but that's again, just getting used to the different environment. They all work slightly differently. Cool. So we've got this, it's in here. Nice. Let's go back to actually doing code. Oop. Let's code the movement. We start by calculating the input direction vector using the global input object in physics process. Slightly differently named because we're in C#. So we need to override something from our character 3D body. You don't want it to return anything, and it's called physics process. And this is the nice thing, even in C#, the autocomplete, once you set up, does come across and tell you what you can override. You see this comes all the way down from node. It's called during the physics processing step of the main loop. Physics processing means the frame rate is synced to the physics, blah, 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 blah. So if you're worried about using Godot in C#, in my experience, and I've not released anything major or done anything major in it, it actually all comes through quite nicely. It doesn't feel like C# is that much of a second citizen, although it is a little bit of porting, but I know they're working on fixing that. And I think that has been sped up quite dramatically with everything going on. Okay, so this is just saying that we're going to call the one in node. We don't need to do that. We're fully overriding it. So first we do var direction equals 0 vector, just so we're resetting this every time. Oh, that should be an equals. If input dot is action pressed, and this is, if you're used to the Unity's original input system, really similar. It's the same as is button. We have is button down. Sorry, I think that's is button down, is button up equivalents. And we'll just fix that as well while I'm looking. Oh, thank you, Poor Ponky, as well. So you have is action pressed. I have to say, this is one thing I don't like about input systems when you have to use a bunch of strings, but it is what it is. Direction.x equals 1.0f, 1.0f. I'm also not used to it. It sounds really dumb. I'm not used to the vector freeze having capital X, Y, and Z. But again, it's just what you're used to. What we're doing here is a really classic way of doing movement, which I will probably tidy up into my own style in a second. Basically, we're just saying, is someone holding the move right button down? That should be that. Oh, hang on, I'm doing this wrong. This should be plus equals and minus equals, shouldn't it? So basically, if someone is holding down the right mouse button or the right arrow button, we're adding 1 to our X direction of this vector. They're holding left, we're minusing 1 from the vector. So if you hold them both down, you won't go left or right. And then we'll do similar for up and down. Do input dot is action pressed. We have move back, move forwards. So we'll have direction dot y plus equals this, and direction y forwards, direction dot y minus equals, like that. Oh, hello Kofi Dev, no, thanks for joining us. Pretty sure there's a funk in input that does this in a one-liner. Surely.y, what's this? Surely.y, surely not .z. Oh yes, because this is wrong, and if I was coding this myself, this would not fly. What I always aligned it to screen, and then Z is in and out of the screen. I hate this way around. It upsets me. But yes, I should follow the tutorial. There's a get vector one. That's interesting. Is that input.getVector? Gets an input vector by specifying 4 actions for the positive and negative X and Y axis. Useful for getting vector input such as from a joystick. Nice. That is nice. That is a really nice shortcut. We're not going to do that shortcut because we're we're doing the tutorial. And also, this is such a common structure that it's useful when you're learning just to use this structure so you know what's going on. Oh, so get vector will do like a circular, so it's more for the analog sticks, yeah. Still, that's cool. That's something I'll experiment with. What I will do is, whenever I'm doing this, I much prefer shortening it down without the brackets, because we don't need them, and it makes it seem like a more contiguous block. Okay. Well, there's an input.getAccess as well, is there? I can type. Not quite as good a shortcut, but still nice. All right, here we're going to make all the calculations using the physics process virtual function. Like process is the equivalent of update in Unity, as far as I'm aware. It allows you to update the node every frame, but it's designed for physics-based code, like moving a kinematic or rigid body. So this is the equivalent of fixed update in Unity. We start by initializing a direction, which we set to 0. Then we check if the player is pressing 1 or more of the move things we defined, and updating the vectors x and z commutes accordingly. These can correspond to the ground axis planes, or the ground plane's axis. These 4 conditions give us the 8 possibilities and 8 possible directions. In case the player presses, say, both W and D simultaneously, the vector will have a length of about 1.4, but if they press a single key, it will have a length of 1. We want the vector's length to be consistent and not move fast diagonally, so we call the normalize method. Fun fact, part of the reason moving diagonally and bunny hopping came about in old games as being faster in stuff like Quake and Half-Life is because they didn't normalize it. Because normalizing is quite an expensive operation. In old games, they didn't think it was necessary. So, how do we do this? The way they're suggesting doing it is if the direction is not equal to vector 3.0, then direction equals direction dot normalize. Oh, that's nice, it's all built in. Then we're doing get node, and node 3D, pivot dot look at position plus direction. Oh, gone off the side there. Vector 3 dot up. Interesting. Okay, so what we're doing here with getNode3D is... What are we doing there with getNode3D? So what we're doing here is we're getting a child node. So our script is running on here. We're saying we want to get something of type node3D called pivot, which is this one here. And then we're calling on this a function called lookat. So this is similar to get child or find in Unity, the get node stuff. Lookat then rotates the node so that the local forward axis minus z points towards the target location. The local up axis points as close to the up vector as possible while staying perpendicular. Okay, so we're effectively saying from where we are, we want to point in the direction we're going. So position is just something that's in the node 3D. We'll probably, I guess it must get it from here in the transform, but then adding to that as we can with vectors to get a direction to point to. Nice. That all, I think, makes sense to me. And we're only doing this if we've got an input, so if our direction isn't 0, because otherwise we're normalizing and calling this for no reason. Yeah, we also get the pivot node and call it lookat method. This method takes a position to look at in global coordinates and the up direction. A node's local coordinates, like position, are relative to its parent. Global coordinates, like global position, are relative to the world's main axis. Interesting. So can we do global position in here as well? Interesting. So in Unity, it's the other way around. You have position, which is the global position, and local position, which is the local one. In here, position is the local one, and global position is the global one. Yeah, I'm going to absolutely make that bug at some point. Cool. Yeah, so in 3D, the property that contains a node position is position. By adding direction to it, we get a position to look at that's 1 meter away from the player. Then we have to update the velocity. We have to calculate the ground velocity and full speed separately. Be sure to go back 1 tab. So the lines are inside the function but outside the condition we just wrote. Yeah, fine. So we can say target velocity.x equals direction.x times speed. I want to do the same for .z. Good guess, autocomplete, but not quite there. So effectively what we're saying is our inputs are always 1 or 0, but then we're using this externalized value here, our speed, to multiply against our vectors in order to allow us to adjust the speed of our character without having to faff with our input. And we can't just multiply target velocity times speed, because that would also affect our up and down, our y, and that's going to be affected by our target, by our fall acceleration rather than our speed. Because normally if in 2D you'd just times it by speed. You just basically just do that. And that would multiply all aspects of this vector by speed. But because one of them is dealt with differently, we don't want to do that. So if not is on floor, they have that. Huh. That's nice, because that's normally a really annoying thing to calculate by yourself. Returns true if the body collided with the floor on the last call of move and slide, otherwise returns false. The character 3D's up direction and max floor angle are used to determine whether the surface is floor or not. Okay, that's really powerful to have built in. Kudos, Godot. Kudos. And then if we're saying if we're not on the floor, if you're not used to C#, that means not. So if we're not on the floor, in other words, if this returns true and we are on the floor, we ignore this, but if it returns false, we run this because we're not on the floor, because what we then do is we accelerate our character downwards towards the floor. You just access delta directly. You're complaining about double floats. Delta is a double, everything else is a float. So we're just casting that from a double to a float. If you know C#, you know that you have to do this cast quite a lot. Okay, and now we've updated all of that, we can set apparently velocity, which is a value from character 3D body. That's why I didn't recognize it. Equals target velocity, then apparently we call move and slide. I assume that is also a method from character body 3D. Yeah, okay. So, if you've not done coding before, this all looks a bit mad, but we're using basically a bunch of different built-in methods and variables to do this. Effectively what we're saying here is we're just saying get which direction the player's pressing. Then we make sure that they don't go faster diagonally than they do just by pressing up or left or right separately. We then are turning our model to look in the direction we're going. We're then calculating how fast we want to move on the ground plane. And then we're saying if we're not on the floor, if we're in the air, then we are saying make our velocity be affected by this fake gravity that we've defined up here. And we're timesing it by delta. Delta is the amount of time that has passed since the last frame. And it's always really important to times movement stuff by your time delta, because that's what makes it frame rate independent. Otherwise, what happens is if you're running in 30 frames per second, you move slower than if you're running in 60 frames per second. Although having said that, we haven't multiplied any of this other stuff by delta, like our X and Y, which I feel like we should have done. We probably should have done. I think they're fudging it a bit because the physics process runs at a set frame rate, which means you don't really, when you're in the physics process thing, have to time stuff by delta. Because if we mouse over here, you'll see the delta variable should be constant. Delta's in seconds. Yeah. For my own happiness, I am going to do this, and we're going to go fix that later when we move too slowly. The way to think about delta is, instead of saying every frame I want you to move 5 meters, when you times it by delta, what it means instead is every second I want you to move 5 meters. And that means it's then frame rate independent. Okay, there's a bit more explanation on the tutorial. This thing returns true if the body is collided with the floor. For vertical velocity, we subtract the fall acceleration multiplied by the delta time of every frame. This line of code will cause our character to fall in every frame, as long as it's not on the floor. The physics engine can only detect interactions with walls, the floor, and other bodies during a given frame. If movement and collisions happen, we'll use this property later to code the jump. On the last line, we call move and slide, which is a powerful method of the character 3D body class that allows you to move a character smoothly. If it hits a wall midway through the motion, the engine will try to smooth it out for you. It uses the velocity value native to character body 3D. That's really powerful. Having these two built in is really, really powerful if you've ever tried to code your own 3D character movement thing. They're the really fiddly bits. That's all the code you need to move the character on the floor. Okay. Got a full code. Let's just make sure I've not done anything dumb. No, mine all looks about right. Apart from this, which is really going to cause us problems, but we'll fix that. Testing our player's movement. Yes, let's save that. Let's go back here. Let's hit the build button. We are going to put our player in the main scene to test it. To do so, we need to instantiate the player and then add a camera. Unlike in 2D, in 3D you won't see anything if your viewport doesn't have a camera pointing at something. Save your player scene. Save. And then open the main scene. You can click on the main tab at the top of the editor to do so. Ooh, I'd forgotten about this. So that means you can have, effectively, in Unity speak, a bunch of prefabs open you can fiddle with. And then also your main scene. Nice. To instantiate the player, right-click on the main node and instantiate child scene. And we want the player one. Oop. Oh, look. Yeah, there we are. Let's double click on that. Yeah, too far. Okay. Nice. Do we get shadows? Hey, and look, because we turned the shadows on earlier. Nice. Just set us back to the right place. This also means now if we move this player up, it's a bit more obvious if I now rotate this directional light, what's actually going on. See that we get like really long shadows versus kind of shadows going that way, and etc, etc. I quite like where I've got it set up, so we'll stick with that. Alright, adding a camera. Let's add the camera next. Like we did with our player pivot, we're going to create a basic rig. Right click. Okay. Right click on the main node and add child node. Create a new marker 3D. What's that? Marker 3D. Generic 3D position hint for editing. Okay. Rename it camera pivot. Okay. Select camera pivot and add a child node. Camera 3D. scene tree should look like this. Yep, my scene tree looks right. Notice the preview checkbox that appears in the top left when you have a camera selected. Oh yeah, you can click it to preview the in-game camera projection. That doesn't look right just yet, but that's useful. Yeah, and it only appears when I've got a camera selected. That makes sense. That is an excellent question, Port Ponky. I don't know what Marker 3D is yet either. I guess we're about to find out. We're going to use the pivot to rotate the camera as if it was on a crane. Let's first split the 3D view to be able to freely navigate the scene and see what the camera sees. In the toolbar right above the viewport, click on View. That one? Oh. Then click two viewports. I mean, it's saying us to do that one, but I don't want to do that one, so I'm going to do that one. It will be really horrible, horizontally split on my screen. Oh, so now I can do like that. And we can have the camera's viewport and the scene on the same one. That's a bit extreme, Port Bonky, that you're going to leave if I did the horizontal split. Don't blame me, blame the tutorial. In the top view, move the camera to about 19 units on the Z-axis. Okay, now I've confused myself because they're talking about stuff. No, that's not what's confusing me. The tutorial's confusing me here. It's saying on the bottom view, which is this one, in our case, select the 3D camera and turn on camera preview. In the top view, move the camera itself. Got it. Right. That's what was confusing me. That I wasn't reading properly, basically. Here's where the magic happens. Select the camera pivot and rotate it minus 45 degrees around the x-axis using the red circle. Yeah. This is where the magic happens, Port Ponky, apparently. Right, yeah, we're using this basically so we can then rotate. Yeah. We're using this pivot so we can move the camera back and then rotate it, but still have the origin of the camera centered here. So if, for example, this was closer in, we'll just rotate the camera viewpoint perfectly here. But now, because of this is here, we're effectively rotating it on a massive crane arm, is the point they're trying to make. Which is good. So we go to transform, I can just do like minus 45. And we get a nice kind of oblique angle, acute angle. You can run the scene by pressing F6. F6. That builds everything. Here's our scene. Yeah, as I suspected, because I've times everything by delta, we're moving very, very slowly. So, what we do is we go to our player. We can do it in here. And then we can say speed. We probably want to times that by about 60, I'd imagine. Go back here. Do this. There we go. Now we're moving around. Nice. We've got a little player moving around. And it's rotating in the correct direction. I don't know why you're asking me if a Node 3D and a camera and a Marker 3D is that different, Port Ponky. I'm learning Godot. But I mean, what we could do is we could go in here. We can say a Node 3D is the most basic 3D game object. Whereas a Marker 3D is just a hint. I guess the point of the camera pivot is you can do this. You can make a bigger gizmo, maybe? I don't know what that means. One of these must be is one of these a Node 3D? So this is a Node 3D. By default it comes with transform, visibility, process editor description. This comes with similar stuff, but also a gizmo extends. Marker 3D is the same as Node 3D, but Marker 3D shows a gizmo and editor. Node 3D is invisible. Is it? I mean, this definitely shows a gizmo and editor. I mean, let's just, for my own sanity, if I do a Node 3D in here. Yeah, no, a Node 3D. I don't think that's necessarily correct, Portponky. Maybe it was correct in Godot 3, but it doesn't seem to be correct anymore because Node 3D definitely has a gizmo. Same as the camera pivot, which was a Marker 3D. Anyway, let's get rid of that. Oh, I see. I see what you're saying. Yes. Basically, a Marker 3D just has a little visible marker here, whereas a 3D Node 3D doesn't. So it's just an editor thing to allow you to see where the center point of our camera rotation is. That's good to know, though. Thank you for looking up the manual there, Portponky. Okay, where were we? We went on a side expedition there. We can see some empty space around the character due to the perspective projection. In this game, we're going to use an orthographic projection instead to better frame the gameplay area and make it easier for players to read distances. Select the camera again, and in the inspector, set the projection to orthogonal and set the size to 19. Yeah, okay, cool. They did blaze right past that in the tutorial, that's true. This is actually another thing I wanted to see when I was experimenting with 3D, how Godot dealt with orthogonal cameras, because Solas 128 is entirely made in 3D but with orthogonal cameras, and it allows you to do all sorts of fun, weird projection tricks. Now, where are we? Here we go, projection. Interesting. Oh no. Interesting. They didn't want me to pick this one, but I was just curious what frustrum was. I guess that's perspective, but you have a bit more control. Yeah, you're actually defining the frustrum directly as opposed to an FOV. Let's not touch that one. We want to set this to orthogonal, and we want to set its size to 19 meters. Yeah, it should look flatter. Now if we go back to play and we move around. Yeah. Basically, we're not going to scale the character with how far they are away from the camera, but we can still sort of show 3D and have shadows. When using orthogonal camera in Godot 4, directional shadow quality is dependent on the camera's far value. The higher the far value, the further away the camera will be able to see. Higher far values also decrease the shadow quality, as the shadow rendering has to cover a greater distance. If directional shadows look too blurry after switching to orthogonal cameras, decrease the camera's far property to a lower value, such as 100. So you can see we've got really rubbish shadows here, because there's a limited resolution in the shadow maps to cover all the space the camera can see. And then, as you see now, because we've decreased it, our shadows now got basically a lot sharper and nicer. Incidentally, you can also see, although we can't jump yet, if I kind of hoik the player up a little bit, press play, you can see we drop down to the floor because we've got that code about dropping down to the floor that we put in the previous bit of the tutorial. That's nice. Let's just reset us to where we were. And yeah, the obvious other side effect of that is if we make the far camera too small, then, man, that comes down really slowly. Things start vanishing because they are being culled. So you can see here, if I now adjust this, you'll literally see that it culls things that are too far. So, as with any 3D stuff when you're doing shadows, it's a lot of tweaking stuff to make the shadows look as good as possible. Oh yeah, and then it said test it. Yep, so we're able to move around. We're not falling through the floor. I can do that with arrow keys. I can do the movement with WASD. Can I also do the movement? I can do the movement with stick. It feels weird on the analog stick that I can only go in 8 directions, but it does work. So that's nice. Perfect. Progress. Definite progress. Alright. Designing the mob scene. In this part, you're going to code the monsters, which we'll call mobs. In the next lesson, we'll spawn them randomly around the playable area. Let's design the monsters themselves in a new scene. The node structure is going to be similar to the player scene. Create a scene again, once again with a character 3D body 3D as the node as its root. Name it mob. Scene, new scene. Other node, character body 3D. I'm going to call that mob. Add a child node 3D and name it pivot. Okay, drag and drop mob.glub. Make sure it's on it. Make sure it's on it. There we go. Okay, so that's our monster is now a child of pivot. So that's all good. Rename the newly created mob node into character. And our scene looks correct. We need a collision shape for our body to work. I mean, so true. Right click on it. Mob node at the scene root. Add a collision shape. We've done this before. We know broadly what we're doing now. Oh, in the inspector, assign a box shape 3D. Okay then. Apparently they want us to play with different collider shapes. That's fine. We should change its size to fit the 3D model better. You can do so interactively by clicking and dragging the orange dots. Not on that one. In fact, I'm probably just going to go back to one viewport now. The box should touch the floor and be a little thinner than the model. Physics engines work in such a way that if the player's sphere touches even the box's corner, a collision will occur. If the box is a little too big compared to the 3D model, you may die at a distance from the monster and the game will feel unfair. Note that my box is taller than the monster. It is okay in this game because we're looking at the scene from above and using a fixed perspective. Collision shapes don't have to match the model exactly. Blah, blah, blah. Okay, so first things first, we need to move this up a little bit. Then we need to squidge it out a bit. And then we probably squidge it this way a bit. Can we get a top-down view? Perfect. Man, I love this gizmo in the side. That makes me very happy. Yeah, that is probably going to feel a bit unfair, so we'll probably just tweak that in a little bit. That's nice. Let's get me a side view. Yeah, that looks okay. We're probably just going to want to move this up a little bit more. Smidge down. Nice. Okay. Excellent. And just go back to... There we go. We're going to spawn the monsters at regular time intervals in the game. If we're not careful, their count could increase to infinity, and we don't want that. Truth. Each mob instance has both a memory and a processing cost, and we don't want to pay for it when the mob is outside the screen. Once a monster leaves the screen, we don't need it anymore, so we should delete it. Godot has a node that detects when an object leaves the screen. Visible on-screen notifier 3D, and we're going to use it to destroy our mobs. When you keep instancing an object, there's a technique you can use to avoid the cost of creating and destroying instances all the time called pooling. It consists of pre-creating an array of objects and reusing them. When working with GDScript, you don't need to worry about this. The main reason to use pools is to avoid freezes with garbage collection languages like C# or Lua. GDScript uses a different technique to manage memory, referencing accounting, which doesn't have that caveat. Yeah, fine. We're just going to ignore all the things about pooling right now. It doesn't really matter in this game at all. Hey, Joe. Is this easier or harder than golf? I think it's probably harder than me playing golf. Maybe easier than you playing golf. If that helps. Okay, select the mob node. Add a visible on-screen enabler, on-screen notifier 3D. That's interesting. Enables certain nodes only when approximately visible. Detects approximately when the screen node is visible. These are again really useful things to have, because this is a right faff to do without some way of the engine telling you. You didn't let Port Ponky down, Joe. I mean, you let yourself down, but not Port Ponky. It's fine. Okay, another box, pink this time, appears. When this box completely leaves the screen, the node will emit a signal. Yeah, we'll no doubt get into signals in a second. But long story short, signals are, if you are coming from C# land, delegate functions that Godot uses to send messages about to allow for decent decoupling of different objects. It's a nice way of doing it, honestly, and I like the fact they link into C# delegates very much. Okay, we'll just make sure this covers the entire 3D model, as we're apparently supposed to. Up, please. Switch that down a bit. Good enough. There we go. That should be fine. These things don't have to be precise. Yes, Joe, I am working through the Your First 3D Game tutorial, because previously I've done all the rest of this getting started stuff. This is the last one, and it also, I'm hoping it will get me to a stage where I can ask or answer a few questions about Godot that I want to know, about kind of lighting, shadowing, and how 3D works in general, because I've got a test little game I want to do to see if I can make both Godot and maybe a couple of other engines I'm going to try fit into my style. Let's put that back over there. Okay, let's implement the monster's motion. We're going to do this in 2 steps. First, we'll write a script on mob that defines a function to initialize the monster. We'll then code the randomized spawn mechanics in main scene and call the function from there. So attach a script to mob. Boop. And yeah, I'm coming at this, Joe, as someone who's used a lot of Unity and seeing where the differences are, where the similarities are, where I get confused because of differences. Oh yes, I should say as well, for people who know what they're talking about, this is basically what we're defining here as an AABB, an axis aligned bounding box, and that's what it uses to see whether or not it's on scene or not. Hence why it's saying change notify AABB down here a lot. Alright, what were we meant to do? Attaching a script. Yes, we were meant to attach a script. Again, remembering we're only allowed 1 script per thingy. So that's moved to capitals. It's going to inherit character body 3D. Object empty. I think that's the same as before. Nice. Okay. Here's the movement code to start with. We'll define two properties, min speed and max speed, to define a random speed range, which we'll later use to define the thing. Okay, so as before, export is the equivalent of serialize. So we'll do public int max min speed, get set stuff, and give it a default. Thank you, autocomplete. You basically got that mostly right. Except the line breaks. Okay, so yeah, we've got a min speed, a max speed defined, and then we do public override void. And again, we're doing this in physics process. So we can just autocomplete that through. We're just filling this in with the move and slide thing that we used previously for our movement. We should be happy, poor Ponky, that Joe is moving away a little bit from puzzle script and doing any external engine stuff. I'm very excited for him. Okay, similar to the player, we move the mob every frame by calling the function character body 3D move and slide. This time we don't update the velocity every frame. We want the monster to move at a constant speed and leave the screen even if it were to hit an obstacle. We need to define another function to calculate the character body 3D velocity. This function will turn the monster towards the player and randomize both its action and of motion and its velocity. This function will take a start position, the mob's spawn position, and the player position as arguments. Will position the mob at start position, then turn it towards the player using the look at from position method, and randomize the angle by rotating a random amount around the y-axis. Below, randef range outputs a random value between minus pi divided by 4 radians and pi divided by 4 radians. Alright. Okay, fine. Well, apparently we're going to do a public void initialize method, and we're going to take in a vector free start position and a vector free player position. Let's do a bit of scrolling because this doesn't quite fit. Okay. Then there's a built-in method called look at from position. What does this do? Moves the node to the specific position and then rotates the node to point at the target as per node 3D look at. Operations take place in global space. So that is actually kind of similar. Autocomplete knows what we're doing. It's kind of similar to what we did here in that we use the look at here, but instead we move it to a position and then tell it to look at a different position. We've used that kind of one of the functions that's called from here already. So that's a nice shortcut. Oh, Joe, of course the first thing you're implementing in Rust is puzzle script related. Okay, we can then use rotate Y, rotates the local transformation around the y-axis by angle in radians. Okay. Then we need to do gd dot random range. Returns a random floating point value between from and to inclusive. Okay. Minus math f dot pi divided by 4 to math f dot pi divided by 4. Why are you complaining? That is a double and it needs to be a float. I said we'd do a lot of this casting. I spent all my time in Unity casting between doubles and floats as well. Hello, greetings, Scar. Thanks for joining us. As you'll see, we're working through the Godot Your First Game in 3D tutorial as someone coming from Unity who's never done 3D in Godot before and has done very little Godot before. Okay, we got a random position. Did we? Did we? Okay. I don't think we have yet, but okay, tutorial. We got a random position, now we need a random speed. Rand I range will be useful as it gives random integer values, and we'll use the min speed and max speed. Random speed is just an integer. Just use it to multiply our character 3D, our character body 3D.velocity. After random speed is applied, we rotate velocity towards the player. Okay. So in random speed equals gd.rand. Oh yes, okay. So I think this is a C# GD script thing. In C# we override the same function and it figures out whether it's using, technically we overload the function. I'm going to be teaching this stuff soon. I think we overload the function so it can figure out that because we're putting integers in, it's going to use the int version, and here we're putting floats in or doubles in, so it's going to use the double version. In GD script, they've got slightly different ways of calling them. Presumably the random position will be passed in as start position, but the tutorial phrases that weirdly. But that's fine. Then again, we can use velocity, which comes from our character body 3D, which, as you can see, we're extending or inheriting from up here because we've attached our script to mob, which is a character body 3D type. So again, this is slightly different to Unity. In Unity, every script basically inherits from GameObject, whereas there's different functionalities you inherit from in Godot, depending on what you've attached the script to, which will probably just take a little bit of getting used to in my head. Just while we're here, move that script. Okay, so anyway. Oh, I've just caused issues, haven't I? Because I moved that while I was editing it. Yeah, that's me. That's my fault. Ignore that. Are you still... Yeah. Yes, shush. Yes, ignore that. That was me. That was me moving stuff while it was being edited. And I knew that would happen if I thought about it. Okay, so velocity equals vector3.forward. Which is fine, times random speed, which we've just calculated, which is fine. Then velocity equals velocity dot rotated. Rotates this vector around a given axis. Vector by angle in radians. The axis vector must be a normalized vector. Okay, rotated vector 3 dot up. Rotation dot y. Okay, so this bit says we calculate a forward velocity that represents the speed. We then rotate the velocity vector based on the mob's y rotation in order to move it in the direction the mob is looking. Right, okay. So effectively what we're doing here is we're giving the mob a random rotation. We're then saying the velocity will always go in the direction the mob is rotated. So in other words, we point it in a direction and then it will just do its random speed in that direction. Okay, leaving the screen. We still have to destroy the mobs when they leave the screen. To do so, we'll connect our visible on-screen notifier 3D node screen exited signal to the mob. Head back to the 3D viewport, I should say. And then then on the right side of the interface, we have node stuff up here. Okay, so we need to click that. This is the one area where if you're using C#, at least in this version of Godot, which I'm using Godot 4, it's not as neat as when you're using GD script. But if you know your delegates, it's basically okay. But effectively all these signals, they're effectively like delegate functions or delegate methods in C# that you can subscribe to and unsubscribe to from other places. So visible on-screen notifier will basically send a signal out whenever it both enters the screen or exits the screen. Node 3D will send a signal out when the visibility is changed, and then Node has these signals and Object has these signals. And basically what you can do is you can hook your methods into that. So when something enters or exits the screen, you can have it call code in other scripts anywhere you like. But importantly, that decouples this visible on-screen notifier 3D from all your other code, because it just calls it and it doesn't know what anybody else does with it, which means it's really easy to build up your functionality in small, separate, discrete parts that don't have weird interaction effects, which is, honestly, and I say this as somebody who has, like, Solus 128 is a mess of code overlapping and all sorts of problems. It's really nice the way Godot does it. Oh, let's not get into that, poor Ponky. Object-oriented programming doesn't require decoupling to be OOP. It's not one of the 4 principles of OOP, and blah, 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 blah. But I agree it is nice to have. Okay, so we select the visible on-screen notifier over here. And you can see, by the way, when you go to different points, they'll have kind of different things. So collision has your collision things. Okay, so we then want when our screen exits the screen. Double click on this. And now basically what we can do is we can say where do we want this signal to kind of be listened to. Now, if you're doing GD script and you do this, it will automatically set up the structure of the method for you. It doesn't work so well in C#, at least the version I'm using, but I'm pretty sure they will have fixed that. So basically what I'm going to do is I'm going to say, if you go to advanced, and you can do extra things, I'm going to select the mob here, and then I'm going to say connect. That will take me into my method here, or into my class here, but it won't make the connection. We just have to hoik that across ourselves. So we've got on visibility notifier screen exited, and that will map. Just lost my chat. There we go. That will map to what's going on over in here. You can see we've got this saying this is connected, and the slight complication here is that the method name structures are different between the two languages, but ignore that for now. So what happens once this exits the screen? This method will now be called. So we can do code in here to do things. What we've done is we've put the queue_free method in here, and that queues a node for deletion at the end of the current frame. When deleted, all of its child nodes will be deleted as well. So this is the equivalent in Unity of the destroy, only it's nicer than the destroy in Unity because it's clearer when the stuff gets deleted, and Unity had some oddities about deleting things sometimes mid-frame that could cause weird issues, which is why if you're used to Unity, you spent a lot of your time checking whether that object or that game object existed before you tried to do something with it, because sometimes it got deleted and then something else tried to access it and blah, 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 blah. Okay, so basically this just means that once it exits the screen, our mob will be deleted, which is what we wanted. So that means we now have, just checking the code, we now have our basic mob functionality sorted, so I'll save that. Alright, let's go on to the next part of the tutorial. Spawning monsters. In this part we're going to spawn monsters along a path randomly. At the end you will have monsters roaming the game board. Nice. So we want to go back to our main scene. Before drawing the path, we're going to change the game's resolution. Our game has a default window size of 1000, 152 by 648. Of course, what a completely normal default size. And we're going to set it to something else. So let's go to project settings. Yes, there are a few weird click-through issues in the editor. They're quite rare. But what's happening there is it wasn't clicking the menu, it was clicking underneath it. As I say, quite rare, and I'm sure fixed by now. Display window 720 by 540. You can also pick its other modes in here, and obviously you can change this from inside your code and etc, etc, all the normal stuff you'd expect. I do also like you can basically tell exactly where you want the window to start or centered and stuff. It's quite nice. Okay, we've done that, so close that. So now if we hit this button, we have a slightly smaller little window by default. We can still move around as we did previously. Alright, like you did in the 2D game tutorial, which I cannot remember, we're going to design a path and use a path follow 3D node to spawn random locations on it. In 3D though, it's a bit more complicated to draw the path. We want it to be around the game view so monsters appear right outside the screen, but if we draw a path we won't see it from the camera's preview. To find a view's limits we can use some placeholder meshes. Your viewpoint should still be split into two parts. Hooray. Oh, that's nice that the different tabs can have different viewports as well. Nice touch. Also, I like the fact that over here in the camera, if we go back to this camera 3D, back to the inspector, you can see this is saying this is an orthographic camera because it's got flat, and if we were to move back to perspective, you can see we actually get a very tiny little perspective icon there, and if we flip it to frustrum, we get the actual frustrum, which, again, not what we want right now. Anyway, let's add the placeholder meshes. Add a new node 3 as a child of the main node, and rename it to cylinders. Add child name, node 3D, cylinders. We use it to group the cylinders, select cylinders, and add a mesh instance 3D. Go to the mesh here, and we want a new cylinder mesh. Set the top viewport to the top orthogonal view. Should be that one. Okay. Interesting. The zoom on the right and left, I'd not noticed that before. Oh, where is it saying to do that from? Top. In the viewport's top left. Oh, from here. We could have just done that. I like this gizmo, so I'm going to use this gizmo. The grid may be distracting. You can toggle it by going to the view menu toolbar and clicking view grid. Nice, but I think the grid's fine. You now want to move the cylinder along the ground plane, looking at the camera preview in the bottom viewport. I recommend using grid. The only slight problem with this is I'm not entirely sure where it thinks the edges are. Can I make you go away temporarily? I can. Okay, move the cylinder so it's right outside the camera's view in the top left corner. Okay, we have this mesh. We can just do that to use snap. So we can then... So there's our cylinder, allegedly. Yeah, I'm a bit confused how it's expecting us I was expecting us to see everything on this one. You're on the preview. I guess we'll just fudge it and say that. I'm assuming this box is the edge of the screen. That's what it's trying to say. It's not clear from the tutorial. Zoom into the tutorial, see if it's any clearer. No, not clearer. Okay. I guess we're just going to wing this a little bit. Because what I can do is if I put it just there, I can just hit play really quickly, see if that's visible. That's still visible. Move that up a little bit more. That's still visible. Yep, so move that up a bit more. Bit that way, bit that way. That's still visible. Nope. Cool. So that should hopefully be good enough. Okay, we can duplicate them as well. Just Control D that, fine. You can right click the node in the scene dock, select duplicate, move the copy down along the thing until it's out of the camera. Yeah, so we can just be like, whoop. Yeah, we'll just, yes, that needs to go a bit more down. And I think we should probably have these be the same out. So just going to do -13, 16. And then we can do both of these, duplicate these, and move these. But again, just going to move them the equivalents for now. So it's nice and clear in my head where they all are. And if we have all of these, we should broadly be able to see them. Although it says they're a bit hard to see in white. Let's make them stand out by giving them a new material. In 3D, materials define a surface's visual properties like its color, how it reflects light. Use them to change the color of a mesh. We can update all 4 cylinders at once. Select all mesh instances in the scene dock. In the inspector, expand the material section. Do I have to click on that first? Yes, okay, so we have to click on the cylinder. And then we have a material section. And assign a standard material 3D to slot 0. Okay, I think we've done that. Click the sphere icon to open the material resource. Oh god, this is getting a lot of stuff in here. Let's give that a bit more space. Oh, that is a lot of options. Oh my goodness. Transparency, shading, vertex color, albedo, metallic roughness emission, clear coat. If true, clear coat rendering is enabled, adds a secondary transparent pass to the lighting calculation, resulting in an added specular blob. This makes materials appear as if they've got a clear layer on them that can either be glossy or rough. Okay. Okay, so there's quite a lot of options in the 3D materials that we're going to ignore for now. I guess we're just going to make this a different colour with albedo. Select a colour that contrasts with the background. Hello. We can now use the cylinders as guides, fold them in the scene dock by clicking that, and we just boop. Although I say that, they're still, why are they? that's because that's supposed to be minus 13. These two should be 13, just to make sure they're out of the way as well. There we go. I'm not convinced those are perfect. If we click play, we can at least just make sure we can't see them. Yeah, it should be fine for now. We'll get that out of the way. Add a child node path 3D to main node. Okay. In the toolbar, four icons appear. Click the Add Point tool. The green plus sign. Ah, over here. Okay. Ah, okay, so extra options for certain things appear over on the right. Lovely. So we have select points, add point in empty space, or what's that? Split segment, delete point, close curve. Fine. Click the center of each cylinder to create a point, then click close curve icon in the toolbar to close the path. Okay, so what it's saying, I guess, is we can just be like boop, 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 close. Okay. Okay, I'm glad it matched up to your expectations. And what's nice about this path thing is because we've still got the snap to enabled, we can now just tidy this all up. There we go. We can now just tidy this up, make sure they're all exactly where we want them to be. After this, to sample random positions on it, we need a path follow 3D node. Add a path follow 3D node as a child of the path 3D. Rename the two nodes to spawn path and spawn location. I'm not sure I entirely understood this with the 2D tutorial because I was getting tired, so it's good to go over this again. A spawn path and a spawn location. With that, we're ready to code the spawn mechanism. Nice. Right click on the main node and attach a new script to it. That to be called that. It's going to inherit from node, which is what our main node was. Cool. Create. Ah yes, and because we're now building it off of a node or a 3D node, we get the default. Well, that's not true. Because I did attach script, I forgot to hang on, let's go back and see if we can figure this out. I want to clear that, and I want to delete that, I think. Yeah. So when you go to attach script, I forgot to change it to empty, like it's suggesting. So if you use the default one, it gives you both a ready and a process method built in, and they are the equivalent in Unity of either the start or the awake. I'm not sure which, but they're basically, initializing one and the update one. So ready is either the start or awake, and the process is the equivalent of the update. We've been doing the physics process, which is the equivalent of the fixed update previously, but it's nice you have that option here as well. So there we go. Let's go back to the empty one like it was expecting. So first we're going to export a variable to the inspector so that we can assign mob or any other monster to it. Okay, so as before, we do export to make it visible, then we do public, packed scene, mob scene, get set. Interesting. I guess packed scene. Oh my goodness. A simplified interface to a scene file provides access to operations and checks that they can be performed on the scene resource itself. Can be used to save a node to a file. When saving the node as well as all other nodes it owns gets saved. Note the node doesn't need to own itself. Okay, I don't understand any of that, but what I'm getting is that packed scene is kind of similar to making a serialized game object, that you can add something in, like add a prefab into this to instantiate it, similarly to how you can do that with game objects, but again, there's no difference between scenes and game objects in Godot. Okay, we want to spawn mobs at regular time intervals. To do this, we need to go back to the scene and add a timer. Before that though, we need to assign mob scene to mob scene. So let's save that, go back here, remember to build so it appears in main. Where are you? Why are you not appearing? Have I done something wrong? Oh, that's not named right. So that should be named right. Let's build that again, see if that fixes stuff. No, that's still looking weird and wrong. So for now, what I'm going to do is, well, clear that, to delete that again. Try that again. This attach script, make that be called the right thing, create, cool. Let's just go back through that process again, because I'm relatively sure I stuffed that up somehow. Mob scene. Save that. Go back here. That's now named correctly. There we go. Cool. So it's appearing up here now. So if you've ever done Java or Unity stuff, you know that if you have issues with the class capitalization not being the same as the file capitalization, it can get really upset. So just something to look out for. I'm just going to move that across there as well while it's closed. Right, now that's there. We can select the main node, drag mob from the file system to the mob scene slot. So where is that? Have we saved this? Oh, we've not saved our mob scene. That's not going to help. Cool. Okay, so we've saved that now. Which now means we can drag this into here. Just like you can in Unity with game objects, it's appearing up there as an assigned thing. Let's save the main scene while we're here as well. Okay, then we want to add timer node as a child of main. Yeah, I remember this from the other tutorial. We did a lot of these. Now, the reason you use timers is it's a way of avoiding using the equivalents of coroutines in Unity. Because a timer basically has a bunch of signals, and the most important one is timeout. So effectively, you can set how long you want it to go, and every time that time runs down, it will fire a timeout signal, which you can then pick up, as we talked about with delegates in other things. And it's a really nice way of doing things at certain time intervals. You can also make it so it's like a one-shot. If it's a one-shot, it will just do it once. So again, you could actually make something that you spawn that has a timer and then it vanishes. And you can also tell it whether it starts automatically or not. In this case, we wanted to go every half a second, and we wanted auto start apparently. So yeah, timers emit a timeout signal every time they reach the end of their wait time. By default, they restart automatically, emitting the signal in a cycle. We can connect to the signal from the main node to spawn monsters every 0.5 seconds. So as before, with this selected, we head to the node dock, double click the timeout signal, we want to connect it to the main node. Just turn the advanced stuff off for now. and we will hit connect, which will open us in here. As I mentioned before, we just have to write this ourselves. If, by the way, you're doing this, the way you convert this to a C# one is it's just you take this name and you make it camel case. So it'll be on mod timer timeout, but in camel case. So we could do private void on mod timer timeout, and that will connect. Cool. In this, we're going to instantiate the mob scene, or game object if you're used to Unity terms, sample a random position on the spawn path, get the player's position, call the mob's initialize method, which we made in here, passing it the random position and the player's position, add the mob as a child of the main node. Pretty standard stuff if you're used to instantiating things from Unity, just done a little bit differently in the Godot style. So we can do mob equals mob scene dot instantiate, and then we need to use generics to say that it's a mob type, and that is very similar kind of structure to Unity if you're used to it, but you call a method on a scene as opposed to a kind of magic method. So in Unity you instantiate and then pass the game object you want to instantiate. In Godot instead, it is instantiate is just a method that lives in the scene itself. But again, really easy brain switch if you haven't done it before. Then we want to choose a random location on the spawn path. So, oh, it's doing var. I don't like var. So we're gonna figure out what that needs to be later and change that. But mob spawn location equals get node path follow 3D spawn path slash spawn, what would that be called? Spawn location. So a thing that took me a little bit to get my head around with this, when you're doing get nodes in Unity, you can just say like find and give it a name and it will search the entire scene, which is really inefficient for big scenes. In Unity, therefore, what I tended to do was use the transforms. You could do like GameObject.transform.getChild or GameObject.transform.getParent to move up and down the hierarchy in your scene. So in Unity, for example, if from here I called some code of .getParent, it would get this. But you could do like transform.getParent.getParent to move up, or from here I would do, transform.getChild spawn path and then .getChild spawn location to move around the scene without searching the entire scene. Godot has sort of piled that in to using strings, but it's all more like styled like a directory path. So as we're in main, we can do .getNode spawn path, which gets this, but then we can do slash spawn location, which will get this. So basically you're exploring down the directory path in your scene. I don't believe you could do that in Unity. I never did that in Unity. But it means your code, if you know where you're going, can be a little bit neater. That's some useful info from Port Ponky in the chat too. GetNode is exactly like GetChild in Unity, except that extra functionality I mentioned. Apparently you can get children by index number 2, and you can find child to search for children somewhere, but that's slow, in the same way that find is slow as well in Unity. Cool. All right, now we do mob spawn location dot progress ratio equals gd.rand gd.randf. Turns a random floating point between 0 and 1. Okay, I get that part. What is progress ratio? The distance from the first index considered 0 as the first vertex and 1 as the last. This is just another way of expressing the progress within the path, as the progress supplied is multiplied internally by the path length. Okay. Okay, that's what I didn't get when we were doing this before. So effectively, here we're creating a path, and you'll see that like the ends technically aren't connected. So depending which way around this path we go, this would be 0, and this would be 1, and then we're basically generating a random number between 0 and 1, which would then get a random location around this path, as far as I'm understanding it. As we've done a closed path, basically it will mean we just get a random location around this closed path. Oh. Is my mouse pointer not visible on the stream? Let me fix that. Because that would be really useful for gesticulating. How about now? I have to actually go back to where we were chatting. Where's the chat one? Okay, good. Thank you for that. So, well, yeah, normally it's turned off for when I'm streaming games, because otherwise you get weird conflicts. So yes, basically this part here will be 0, and this part here will be 1, and then it means when we pick a random number between 0 and 1, we're getting a random location around this path. And I think that's what the point of this is called a path follow 3D. Because the path 3D just generates the path, allows you to make the path. The path follow 3D allows you to sample off this path. So yeah, that is good to know. Right, let's go back here. Let's fix our path. Hello, Jan. Well, in part, I'm learning Godot because I started learning Godot before the Unity stuff happened, but then life and day job happened and it kind of got put on a back burner. The Unity stuff has certainly sped up my desire to investigate other engines, and not just because I use Unity for making games, but also because I'm considering I teach games design and stuff in university level, and we're thinking about potentially what engines we want to teach to students in future as well. Alright, so going back to here, this is effectively saying that we want to move our path follower to a certain location on our path, and then we're just randomly setting it on a random location on that path. Oh yes, I was going to say, what does this? This returns path follow 3D, because as I say, I don't like var. It makes the code harder to parse. Well, no, that's the thing. I like Unity. I still really enjoy developing in Unity, and I'm sad that it might not be something I develop in future, but it is what it is. I also used to develop an action script. It's not the first time this has happened. It won't be the last time this happens. It is the nature of things. All right. Let's make vector player position, if I can spell, equals get node player that dot position. Yeah, so this is always a bit confusing. I know this always confuses students when we talk about this. When you have the thing you're trying to find named the same as the actual type or the class on it, it gets confusing. But basically we're saying get node of generic type player that is also called player. So this is, we go to the inspector, a player type, because that's the class we gave it, the class name we gave it in here. So that always confuses students when they first do that. So it's one I'm quite used to handling. All right, let's just make that max again. Then mob dot initialize mob spawn location dot position and then player position. Yeah, okay, cool. And then add child mob. Right, now let me try and process this to make sure I understand all of this is what's going on. So up here we are instantiating our mob scene, which is like our mob prefab that is just this thing. We are then getting a random position. Well, we're then grabbing the node, which is the path follow 3D node from our scene structure. So because we're here, we go here and then here and grab this. We're then using that abilities for progress ratio to sample a random place on the path that it is linked to. We're then again going down here and grabbing this, which is the player, and getting the player's position. We're then calling the initialize method on the thing we've just instanced, passing it its random location that we've generated from here and the player position. So in here, it will look at the player, it will then rotate in a random direction and fire in that random direction. Cool. Okay. So yeah, we've got randef produces the random value between 0 and 1, which is what the path follow node's progress ratio expects. 0 is the start of the path, 1 is the end of the path. Yeah, okay. We can now test the scene using F6. Yeah, let's go do that. Sorry to hear you were doing stuff in Unity, Jan. Yeah, I hope you enjoy making a Stalker knockoff in Godot. Part of the reason I'm testing Godot on a couple of other engines is to figure out if I can do my sort of visual style in the engines in a way that makes me happy as well. But we're far off that. We're just baby steps with 3D at the moment. Alright, so now if I hit play, apparently we will have crimes. Oh, also there's a lot of errors in the debugger. Uh-oh. Method not found. Method not found. Have I named this wrong? I have named this wrong. That's supposed to be on mob timer timeout, not on mod timer timeout. Cool. That's a useful error message. Well done, Godot. Let's see if that's any better now. Nope. Still unhappy. So what have I done wrong? Yeah, Scar, that's because I'm using C#. This is the one bit where it's not as smooth as with GD script. With GD script, it's more obvious, but there's lots of other things I don't like about GD script. I'm also a couple of versions of Godot behind because I didn't want to update it when I already started the tutorial. So it might be improved on 4.2, which is out or coming out. But it's the only issue. It's the only kind of slight part in this version I think is a bit messy, but it's also not a big deal. Hello, the codec. If you're connecting from the editor, you'll need to change the default name of the method to the method used in C#. Interesting. 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 Okay. That actually makes sense. That means that we've got an error somewhere else as well. Oh, it's... Okay, so let's grab that. Put that in there and connect. Save that and let's see if that fixes the problem. Ah! Thank you very much, chat. That was very useful. Ah! Oh, interesting. We've got a different bug that we need to investigate because they're all apparently getting stuck. which I guess we're going to fix later. Yeah, for now they bump and slide against one another when their paths cross. We'll address this in the next part. Nice. That does also mean, yeah, I was about to say, that means our other signal about when they're leaving the screen will also be broken. So we need to change that as well. In the mob thing, this one needs to change to this one. Save everything, save everything. Okay. Okay. No more debugger errors. Nice. Nice, okay. Hint click remote in the node tree. What are you saying, Paul Ponky? I don't understand. So when I'm playing, what? Oh, over there. Oh, that's really useful. Thank you. They are indeed being removed when they go off screen by the look of it. Because if we now go back to this one, yeah, there's a bunch staying on screen, but we can see them coming. We can see that some of them are vanishing, which is what we want to see. Nice, perfect. Alrighty. It's good doing this on stream with some people who know what they're doing. Alrighty. Just check something really quickly. Just reset the music so it doesn't run over, because I had this on a previous time I was streaming and it then YouTube helpfully picked something very copyrighted, which caused issues. You can also click on them and start editing it all in real time like the inspector. Yeah, that's good, because it's a bit weird that it opens it out separately, but the fact you can still do that is nice. Alright, next. Jumping and squashing monsters. In this part, we'll add the ability to jump and squash the monsters. In the next lesson, we'll also make the player die when the monster hits them on the ground. First, we have to change a few settings related to physics interactions. We're going to talk about physics layers, apparently. That's good. Physics bodies have access to two complementary properties, layers and masks. Layers define on which physics layers an object is. Mask controls the layers that a body will listen to and detect. Yeah, so that's pretty classic if you're coming from Unity World as well. This affects collision detection. When you want two bodies to interact, you need at least one to have a mask corresponding to the other. Yeah, blah 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 blah. Stuff, extra stuff. By default, all physics bodies and areas are set to both layer and mask 1. This means they'll all collide with each other. Physics layers are represented by numbers, but we can give them names to keep track of what's what. Cool. Setting layer names. Let's give our physics layers a names. Go to Project Settings. Layer names. Layer names. Oh, okay, so there's rendering layers for the camera as well. That makes sense. 3D physics. You'll see a list of layers. Apparently we can have 32 layers by the look of it. You can set the names here. Name the first 3 layers. Player. Enemies. And world. Cool. Now we can assign them to our physics nodes. In the main scene, go to ground. In the inspector, expand the collision section. That'll be that. Yeah, nice. Now when we mouse over them, we get their names as well. And yeah, 32. Okay. The ground is part of world, so we want it to be part of the 3rd layer. So, boop. Then toggle off the mask by clicking it. Yep. Yeah. Click the link button to toggle off the first layer and toggle on the third one. Then toggle off the mask by clicking it. As mentioned before, the mask property allows a node to listen to the interactions, but we don't need to have collisions. Ground doesn't need to listen to anything. It's just there to prevent creatures from falling. Now, note that you can click to see a list of... Also nice. Okay. Are you meaning, Jan, what game am I making right now? Or what game kind of more generally am I making? Get the music back on. Right now, I am going through the Godot Your First 3D Game tutorial that is on the Godot documentation, because it's a really good way of going through and learning all the different features that are like the basic introduction stuff to Godot 3D, and I'm slightly ignoring it and slightly tweaking it where I want to, but basically I'm still in a learning process very much. Okay, player and mob. Let's go to player. No, we've already got this. Let's go in here. Select the player node. Set its collision. Let's see. Yep, that's correct. We want it to collide with both enemies and world, but not with itself. I guess it doesn't matter. Yep, that's right. Then we save that. Save that, open the mob scene. For mobs collisions, this should be layer 2, because that's the mob layer, or the enemy layer. Set its collisions, unset its collision mask, leaving it empty. These settings mean the monsters will move through one another, but because I guess we've set it in player, that players can hit both the enemies and the world, they still should hit us. So if we hit play here, let's just check. Yeah, okay, so they go, okay, so they're going through each other, but they can now also just like push us off the screen. Okay, cool. Off we go. Yes, it's called Squash the Creeps, is what the tutorial has called it. Oh, I have no idea. I've not gone anywhere near like the FPS controller script stuff, but I will say it's kind of functions for character body 3D stuff. Having move and slide and is on floor is already super powerful. Okay, the mobs don't need the world layer because they only move on the XZ plane. Apply gravity to them. Fine. Jumping. The jumping mechanic itself requires only 2 lines of code. Open the player script. We need a value to control the jump strength and update physics process to code the jump. After the line that defines fall acceleration, that's here, add jump impulse. So we need to export again. Public int jump impulse. Pulse. Then we want get set. And give it a default of 20. Oh, no, thanks for the offer, Jan. I think it's okay for now. Just bumbling through this anyway. The tutorials are pretty good, so there shouldn't be anything too missing. Slide code block. So this doing target target velocity. Yes, that means it needs to go before that. Okay, so if is on floor. Oh, no. That's a weird. Thank you all to completely mess it up. If it's on the floor and input dot is action just pressed, which is the equivalent of is button down in Unity, jump. Then we do target velocity dot y equals jump impulse. Semicolon, come on. All right, so basically we're doing the opposite. Where here we were saying if we're not on the floor, we want you to fall. Here we're saying if you are on the floor and the input is button has just been pressed, then we jump. Now I think I'm going to simplify that code because it could be better. But there we go. Now if we press space, we can jump and land. That's interesting. By default, we can land on other things, and actually Godot is good enough with its physics engine to do moving stuff. Oh, that's actually quite impressive. Normally, moving platforms and stuff are a bit of a nightmare. Is it a good idea to switch simple if statements into switch cases? No, in my opinion. In fact, it's normally a bad idea because it's less clear. And in this case, we want to make it's not if else. We want to make sure they're all triggered separately. So I think making that into a switch would make it less clear. What I would do, however, in this case, is probably else if this into this format. That should, I think, be equivalent. Because basically, if we're on the floor, we run this. If we're not on the floor, then we'll test this. Yeah, Paul Ponky will give you a much more technical answer than me. I normally say that they tend to be less clearer and harder for people to understand, so I tend to avoid them unless they're super necessary. Yeah, there we go. So our code's now equivalent. I'm using my Xbox controller to test, and it's all working with the jump on the A button. Nice. What I've done there should be a lot quicker, because assuming that is on floor is quite a complicated method, we don't want to have to call it multiple times when we don't need to. And generally, especially with 3D physics stuff, I think you want to avoid calling stuff that does a lot of raycasts. I think the thing to be careful of, Jan, is premature optimization. You don't want to think about every single bit. Is this the fastest way I can do it? Because in most cases it just won't matter. It's much better to code stuff in a way that's clear and understandable for you and your team, and then to test for bottlenecks and optimize later where you need to. Because otherwise you're going to spend more time writing your code, and it's less likely to actually be finished. Basically, Port Ponky saying once you have enough if statements that it annoys you, change it to a switch. That's basically what I do. Okay, cool. So we've got the jump. We've done all of this stuff. Yeah, cool. Now we need to move squashing monsters. Let's add the squash mechanic. We're going to make the character bounce over monsters and kill them at the same time. We need to detect collisions with a monster and to differentiate them from collisions with the floor. Well, that's where the code change I've done might cause issues, but we'll find out if it does. To do so, we can use the Godot's group tagging feature. Open the mob scene again, okay. Select the mob node, okay. Go to the node doc to see a list of signals. The node doc has two tabs, signals and groups. Signals we've already used. Groups, which allows you to assign tags to nodes. Click on it to reveal a field where you can write a tag name, enter mob, and add. Cool, okay. This is actually something I was wondering if it had as well. Unity has this really powerful get all game objects with tags function, which is really useful when you're ending a level and you want to delete all the enemies or all the bullets. And I'd imagine that Godot would have something similar. This will be the something similar. Yeah, I mean, that's fine too. And if you find them clearer to read, do it that way. Especially if you're working with your own in a team of one. Yep, that's all fine. An icon appears in the scene dock to indicate the node is part of at least one group. How's it? Oh, over there. That's the scene dock. Ah, node is in this group. Nice. Useful. We now use this group from the code to distinguish collisions with monsters from collisions with the floor. Yeah. Head back to the player script code. At the top, we'll need another property, bounce impulse. That's fine. We'll just hoik this and call it bounce impulse. And it's slightly less than our jump impulse. Then after the jumping code block we added above, add the following loop. Move and slide, Godot makes the body move sometimes multiple times in a row to smooth out character's motion. So we have to loop over all collisions that may have happened. In every iteration of the loop, we check if we landed on a mob. If so, we kill it and bounce. This code, if no collisions occurred in a given frame, the loop won't run. Alright. It appears to be saying that we need to put it at the bottom of this script. Okay, so for int, I'm not calling it index, stuff u, is less than get slide collision count. Returns the number of times the body collided and changed directions during the last call to move and slide. Okay, that makes sense. Hence why I need to put it after move and slide. I guess it's I++ in there. Is that what you want from me? Yep, fine. Close. Close that, open that. We get one of the collisions with the players. So apparently the next line is kinematic collision 3D collision equals get slide collision I. Okay. Say if collision dot get collider is mob. Oh, that's horrible code. If vector 3 dot up dot collision dot get normal is greater than 0.1 f, mob dot squash, which we've not written yet, target velocity dot y equals bounce impulse. Right, okay, so that's slightly ugly code. Let's try and pick apart what that does. So this bit iterates through all the collisions that occurred this frame, because we might have multiple ones because of this. Smoothing out the character's motion. This then gets us one of the collisions, whichever one we are in the loop. Then this is saying, is the collider of type mob, I guess? Yeah, if the collision is with a mob. Yeah, I'm not 100% sure on that. We'll come back to that. We then check if we are hitting it from above. So vector up dot. So we're doing the dot product of vector up and the collision normal. Okay. And then we squash it. Fine. So this and this both come from character body 3D. Get slide collision returns a kinematic collision 3D object that holds information about where and how the collision occurred. For example, we use its get collider property to check if we collide with a mob by calling is it in group. So this is the equivalent of is in group mob. So I don't know why we're doing the local. Interesting. I'll come back to that. What is the dot thing? What, this? Oh, that's dot product. That's when it calculates. Oh god, I always confuse the dot product and the cross product. It's when you're calculating the angle or the resultant something else between two vectors. So we've got this vector dot up, which is the vector that points straight up, and then we've got the collision vector, and we're basically trying to see how, I think the dot product is how similar those two vectors are, and if they're it's I can never remember which way around it is. It's like if it's 1, it's perpendicular in one direction. If it's -1, they're perpendicular in the other direction, and if it's 0, they're the same. So we're basically saying if it goes slightly positive, then we must be above them when we collided with them, I believe. But my geometry when it comes to dot and cross product is not perfect by any means. Okay, so this is saying we're getting the collider, and then we're saying, is it of type mob? And then I think we're assigning it to mob. So I think this is a slightly odd C# structure, where this is returning a Godot object. Mob is a type of Godot object, but we're basically doing a comparison and an assignment in one here. So we're saying if it's of type mob, then put it in mob, and then we can call it later. Oh, here we go. It's got an explanation. To check that we're landing on the monster, we use a vector dot product. The collision normal is a 3D vector that's perpendicular to the plane where the collision occurred. The dot product allows us to compare it to the up direction. With dot products, when the result is greater than 0, the two vectors are at an angle of fewer than 90 degrees. A value higher than 0.1 tells us we are roughly above the monster. We're calling an undefined function mob.squash, so we have to add it to the mob class. Yes, let's go do that. So I can stop talking about dot product. Public void squash. Emit signal. Signal name dot squashed. Q3. Oh yes, okay. So we haven't actually defined this signal name yet. So we need to go. We need to define it up here. Yeah. This is what I was meaning about them being delegates in C#. We can go public delegate void squashed event handler. Do you not have a squashed? What have we done wrong here? We haven't defined it as a signal. There we go. So this is the other side where C# and signals gets a little bit squidgy. We have to actually define our signals if we want to emit custom signals. In GDScript, you just say signal squashed, and it kind of all works, because then you can just do squash.emit. In C#, because it maps to delegate functions, we have to do this slightly more roundabout way. We first of all have to kind of decorate it that it is a signal, and then we have to do signal name and then event handler. in that format, and then you can emit signal and then do signal name dot your signal name, and it all works. So what we're doing here is if we land on a thing, we're calling squashed, making us bounce. We're then calling here where we emit the signal, and then we delete our mob. We're then going to use this signal to do other stuff, to do the score and things later. But now if we go back here, that should mean we can jump around and bounce off enemies. Yeah, there we go. Boop. 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 Nice. Boop. So that is working. We can jumpy and bouncy. Boop. It's not perfect because we can kind of hit them on the up bounce, but that's probably because we should have already died before we jumped. And we'll fix that and tidy that up in a little bit. This is strange. This is strangely satisfying. Boop, 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 boop. One thing I really want to try is if I go to player, let's just make this bounce impulse 30. Now, boing. Yeah, we should bounce higher. Just gives us a chance to hit more enemies in a wanna. Our rotations do not necessarily look perfect. There's some oddities going on with the way the enemies are being rotated, but ooh, interesting. When we were doing the spawn path, did I make sure they were all the same height? They are all the same height. Okay. Check the mob script. Is this about the rotations? I do rotate their angles. That's what this is supposed to do. Oh, you're entirely right, Codec. It will be that, yes. It'll be because they're looking at the player when we're in the air, so they'll be looking up a little bit. That is a very good spot. So if I wanted to fix that, what I could do is I could basically put player position.y equals 0 here. That should fix that up. I don't think it told me to do that in the tutorial. Now I'm wondering if I just missed some code. Let's see if I can find that code again. No, it didn't. But let's see if that fixes it. Because when you're learning stuff, it's always a good idea to just twiddle about with things, make sure. Oh, it's now also there we go. My much higher bounce is working as well. Yeah, there you go. Yeah. Good shout, the codec. Oh. It is quite hard with this slightly oblique angle when you bounce really high to see when you're going to land on the enemies. But it is very satisfying to try and land on as many of them as you can before you land. Again, like a version of Keepy Uppy. Nice, alright. Parent the camera to the player character. With how the scene is set up, that is going to cause issues. But we'll give it a try, as it's easily undoable. Oh, well, don't tell a lie. That actually worked a lot more smoothly than I was expecting it to. It just now means we can see people, like enemies, spawning around us. Oh, we can see our little magenta way markers as well for the edges. Oh man, that 3D camera really needs some smoothing. That is horrible. Anyway, that's not what we're doing. So let's undo that. Okay, perfect. Nice. All right. We're actually not too far off the end of this. So let's do killing the player. We can kill enemies by jumping on them, but the player still can't die. We want to detect being hit by an enemy differently from squashing them. We want the player to die when they're moving on the floor, but not if they're in the air. We could use vector math to distinguish the two kinds of collisions. Instead though, we'll use an area 3D node, which works well for hitboxes. Okay, head back to the player scene and add a new child node, area 3D, and call it mob detector. 3D area for detection as well as physics and audio influence. Okay. Mob detector. Add a 3D shape collider at the underneath it. Collision shape 3D. Give it a cylinder shape. Okay. Here is a trick you can use to make the collisions only happen when the player is on the ground or close to it. You can reduce the cylinder's height and move it up to the top of the character. This way, when the player jumps, the shape will be too high for the enemies to collide with it. You also want the cylinder to be wider than the sphere. That way the player gets hit before colliding with and being pushed on top of the monster's collision box. The wider the cylinder, the more easily the player will get killed. Yeah, okay. So we open the... Let's just do this top down for now. And we can set that to the scaling one. Let's make it a bit bigger. Let's make it a bit bigger that way. It's broadly okay. That's making me realize that whoever made this Blender model didn't center it perfectly. Then we want to go to a side point of view. And shrink that down. Move it up. Yeah, let's see if that works. Oh, hey VFig. Thanks for joining us and also answering the question that I was not feeling qualified to answer. All right, let's go back here and turn off its monitoring property, or its monitorable property. So monitoring, if true, the area detects bodies or areas entering and exiting it. If true, other monitoring areas can detect this area. Okay, so we want that one off because we only want to test other things coming into it. We don't care about other things being able to detect this. Oh yeah, thanks. I don't link them. Thanks to the codec, you're right. I forgot we have to do it in here. This is one thing I don't like about the Godot interface, is the fact that this arrow and clicking here does entirely different things. That always confuses me, and it confused me when I was doing the earlier tutorials as well. Because it does feel like it's hiding it a little bit. But thank you for spotting that codec. That was useful to know. Right. So let's change the radius. Well, we're here, so let's do the height. So let's do that 0.1 meters. And then we'll go to top down. Radius to 1. 0.2. 0.1. How does that look? Not 11, 1.1. Okay, I think 1 is probably about right. To be fair. Then we want to move the collision shape up. Probably just a smidge more. That looks a bit big now, but we'll leave it. Right, let's go back to the mob detector. Where were we? Then remove the collision layer. We don't want it to collide with anything, but we want it to detect enemies. So in other words, it can no longer collide with anything, but it will be able to detect enemies. So basically we can use collision shapes really easily as either colliders or triggers or both, which is really nice. When areas detect a collision, they emit signals. We're going to connect one to the player node, select mob detector, go to node, go to signals. Click the body entered, just this one. Body entered. And as we learnt last time, let's just rename this. Grab that. Yeah. So it will only emit things because of the mask when the enemy physics layers will go into this, which is what we've got the mobs in. Okay, so we are going to connect this to player, I believe. So we'll hit connect there, go into here. Let's put that over here. Private void boop. And it passes by default a node 3D body. So we'll pass that in. Okay, code-wise we're going to do two things. Emit a signal we'll use later to end the game and destroy the player. We can wrap these operations in a die function that helps us put a descriptive layer on the code. Okay, so we can do private void die. And again, we're going to emit a signal, which means we need to define the signal first, which we do by doing signal, public delegate void, hit event handler. Which now means in here we can emit signal name dot. Let's try that again. Signal name dot hit. Signal name dot hit. Perfect. And then that will delete our player. Nice. Okay. Then in here, we're basically just going to call that method up there. I probably wouldn't do this if I wasn't following the tutorial. That feels a bit unnecessary, but sure. Try the game again by pressing F5. If everything's set up correctly, the character should die when an enemy runs into the collider. Note that without a player, the following line gives errors because there's no player. Yeah, fine. So let's run everything again. Get my controller back. Yeah, cool. So we can get hit and we get destroyed, but now we're getting errors because we don't have an object. Because when we spawn the mobs in here, we're trying to do get node player, but that no longer exists in our, we go remote, that no longer exists in here. So it's throwing errors, but that's broadly what we'd expect. Now the other thing I want to check is if I jump, I can still land on the enemies without dying. Yep, mostly. Maybe need to just move this collision shape up a bit further, just to ensure that we've still got, yep, so still colliding. Yeah, still colliding, that's fine. And let's just check that we can still land on people. Boop, 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 boop. All right, that feels a bit better, though I will admittedly turn down our bounce value because it is a bit extreme. It was 16 previously. As the chat is having a lovely conversation about dot product, great. Okay, the player colliding with the player and dying depends on the size and position of the player and the mob's collision shapes. You may need to move and resize them to achieve a tight game feel. That's all good. We can use the player's hit signal to end the game. All we need to do is connect to the main node and stop the mob timer in reaction. Open the main scene, select the player node, and in the node dock, yeah, here we go. So you can see that we custom defined an emit signal and it's appearing in here. That's what we did with the combination of this public delegate here. And so this actually defines it, I believe, as something that will appear in here. And this is what actually emits it. So we define it so it appears, and then we make sure we emit it somewhere so we can have a result. So, connect the hit signal to the main node. Go in here. So what we do is we do this. Then we can do on player hit in here. Hopefully this is something they'll fix if they haven't already. Yes, VFig, I'm doing C# with Godot. Probably explained that before you arrived. Basically, I really didn't like GDScript. I didn't get on with it for a bunch of reasons. And also, I want to utilize my C# knowledge that I've had from doing Unity for ages. And apart from the signals needing a bit more work, and they're slightly less connected than GDScript, the integration between C# and Godot has been really, really good. So I've been really impressed. I think you can modify that method naming logic in settings. Hello. Hello, Wind. That's very nice. Oh, I love C#. I love it. I love it with mouth. That's very interesting. Thank you. I'll go do this just for now, and then I'm going to go have a look at that. So this should now get called when the player gets hit, because the player gets hit. When the player gets hit, we fire a signal that goes to this method. We then call this method, which then emits this signal called hit, which we're then connecting back over here, which we can now do get node timer mob timer dot stop. So again, we're doing here, we're calling a child, which is this thing, and then we're stopping it. Okay. If you try the game now, the monsters will stop spawning when you die, and the remaining ones will leave the screen. You can pat yourself on... Oh, apparently you can pat yourself in the back. Impressive. You prototyped a complete 3D game, even if it's still a bit rough. Well, let's see if it is working as a 3D game. Okay. Immediately hit something. So we probably still need to tweak the collision volumes a little bit. Apparently we really need to tweak the collision volumes a little bit. Come on, can we still land on things? We can still land on things. Okay. Okay, this is clearly not fully working. Clearly stuffed something up because we're still doing the null thing. So... node signals from our player... doing on player hit, which means this is not stopping properly. It's on player hit. That's on player hit, so that should be the same. Oh, and it's private, and it can be private. That should be fine. The other one's been private. Yep. So there's obviously something not quite working. Now, one thing we can probably do, I think this works, is I can Oh, yeah, no, hang on. Debug that, and then see if that gets called. Ah, for flip's sake. Did I do that again? Ah, for flip's sake. Thank you. Every time with mob I spell it wrong. Perfect. That is now working. That's one of those things that I definitely would have hunted down, but it would have taken me 10 or 20 minutes by myself. Alright, so player dies, stuff no longer spawns. No, it's my, like, I always confuse B's and D's. I don't have dyslexia, but there are certain characters that I very often mix up. Especially when I'm typing. Alrighty. Blah blah blah, code checkpoints. That's fine, it's all now working. So, the next bit, yeah, it looks like we're going to get to the end of this tutorial, which would be nice. Next bit is add score and retry options. As that all is broadly working. So in this part, we'll add score, music, and ability to restart the game. We have to keep track of the current score in a variable and display it on the screen using a minimal interface. Sure. We use a text label to do that. In the main screen, in the main scene even, add a new child node called control to main. Oh no, hang on. Use a new child called control. What's this? All user interface nodes inherit from control. The control's anchor and offset adapts its position and size relative to its parent. Okay. And we call this user interface. That's another thing that I'll be interested to find out about Godot, is how it does, if it has a Text Mesh Pro embedded text in world thing, because I hate overlaid 2D interfaces on 3D games and always work around it. But that's just a me problem. Okay, add a label node and name it score label. One thing I do like, incidentally, if we go back to child nodes, delete this, I like that there are kind of color differentiations. So, you know, it's not perfect for everyone, but it's nice that the 3D stuff is all red, the 2D stuff's all blue, and the kind of UI stuff's all green. It is helpful for me, what we've not been colorblind, to differentiate them quicker. That's good to know, VFig. It's one of those things I will experiment with at some point to see how good it actually works. But while we're here, I suppose... I don't know if I can see it easily in here. I guess there was that there was that other one somewhere. Let's see in label. Ah, there we go. Label 3D. Displays plain text in a 3D world. Lovely. I got there just before you, chat. But it's appreciated. Alright, in the inspector, set the label's text to a placeholder like score 0. Also, the text is white by default, like our game's background. Need to change its color to see it at runtime. Scroll down to theme overrides. Okay. Expand colors. Enable font color in order to tint the text to black. Yep, fine. Finally, click and drag the text in the viewport to move it away from the top left corner. The user interface nodes allow us to group our UI in a branch of the scene tree and use theme resources that will propagate to all its children. Okay. Just putting it somewhere, are we? That's interesting. If I hold down control in this, it allows you to do set 4040. I don't know why 4040. Fine, we'll put it there and see what happens. So let's select this in the inspector, create a new theme resource in theme theme, I guess. Click on it to open the theme editor. Oh, goodness. Oh, my goodness. Okay. Wowzers. So that will show us what all of our different elements look like with our theme. Nice, I guess. By default, your theme only has one property, the default font. Okay. It's not basic. It's not that weird. It's just basically what this is showing you is none of this is stuff you can interact with, but it's showing you how all the different elements of your interface will look with your defaults. Oh, it's got a color selector by default. That's nice. So, like, it's showing you disabled or not active tabs and things as well. Okay. Now, the only bit I don't understand is it's saying by default, a theme only has one property, the default font, and I can't see where that lives. Ah, up here. Right. This one expects a font file. It takes TTF and OTF. And it's given us a font with our initial scene setup download, so I guess I can just bloop that into there. Yeah, nice. So you can see that as we put that in there, it updates what everything will look like. That's quite sweet, actually. It's a default font size of 22. Again, that's actually quite nice. Okay. Kudos. All right. Let's up that all back down. And then if we press play, we should see our score appear somewhere. Yeah, that's fine. Now, honestly, I don't think it feels that heavyweight. I think that's basically just the defaults that it should be. But the difficulty is it's almost always, theme stuff is almost always an engine's absolute gubbins. Where's its actual position in real space? Okay, well, chat is happily disagreeing with me. That is absolutely fine. Oh, there it is. My goodness. That took some, that's deep. It's fine. As I say, I don't like UI stuff in any engine. So in Solus 128, everything was built in engine using like game objects. It's same in CRT7, and no doubt it'll be the same whatever I make in Godot. Because it just feels nicer to me, feels more coherent, and then also scales properly and nicely with different screen resolutions. You are not a good teacher, VFig. I would not go into the education professions. You're supposed to support your learners. Tisk. Right, anyway, let's keep track of score and let's actually use this thing that I've been fiddling with. Attach a new script to score label and define the score variable. Cool. Okay. Where is it? Attach script. Score label. Create. We immediately close that because when you attach scripts, it puts them in weird places. Oop. Go. I'm not the teacher either. I'm still learning. Oh, and I forgot to change the version. This is what I was talking about. Oh, the default. I was sort of talking about before. This is the equivalent of your start or awake. This is your equivalent of update. We can just remove those for now. Private int score equals 0. the score should increase by 1 every time we squash a monster. We can use their squashed signal to know when that happens. However, because we initiate monsters from the code, we cannot connect the mob signal to the score label via the editor. Instead, we have to make the connection from code every time we spawn a monster. Makes sense. Open the script main GD. Oop. At the bottom of the onMob timer timeout function, add the following line. Mob.squashed. Okay. Plus equals get node score label user interface / score label. Dot on mob. Oh, tutorial. No, bad tutorial. Tell me to make the method in here first. Public void on mob squashed. So in here we just up the score and text equals. Okay, I'm not doing it how the tutorial is suggesting I'm doing it because that's horrible and ugly. So I'm just going to do it that way. Alright, so the reason it's always better to do the receiving method first is then the autocomplete can help you over here. Because then when I do dot, I can then do dot on mob squashed and it appears nicely. Okay, so what have we done here? This line is again a bit complicated. In mob, we have to find a public delegate function called squashed event handler, which Godot does some magic in the background to just mean, as we learned from here, there is now a signal called squashed. Then what we can do in in main, is we can subscribe to that delegate. And that's what I meant, that signals fit in really well with C#'s general delegate structure. Because what we're saying, like mob, this thing here, its squash signal, or its squash delegate, I want it to call the method that I've plus equaled to it. And in this case, we're then using our getNode structure from before to say getNode of type score label, and because we're in main, we then have to go user interface and then / score label to get to it, like it's a directory structure. And then once we're in score label, because we have this method called onMob squashed, and we have to make it public in this case, so we can subscribe to it from the code, otherwise we can't see it from the other code. Obviously, we can then grab that. So it's kind of doing a lot of things in one instance. Oh, vfig. I really like signals and delegates. I use them quite a lot in Unity as well, so I am on the opposite side of the fence from you on this. I think they make your code a lot neater because you don't have the coupling. But again, everyone has their own ways of doing things. I like this because I'm used to using delegates and subscribing and unsubscribing to delegates using the plus equals. Because the other thing you can do, if at some point in our code we don't want this method to be called anymore, we can do this, but we can just do minus equals. And that means when mob squashed signal's called, it will no longer call this method, which I really like. No, if you've designed your game properly, ordering, I'll rephrase that. You can design your code so that ordering doesn't matter. And I come from the Unity environment where update and those methods, they can happen in any order. So I'm used to designing code that doesn't have that sort of ordering effects. Now, there are some stuff that I do care about ordering, and especially in Solus, and I fixed that, but yeah. I like signals, I like delegates. I also like the fact that in this, you don't have to do the really annoying thing in Unity and default C# signals. We have to check if the signal isn't null, which really annoys me, because the whole point of subscribing and unsubscribing to signals is it should just call everything in a list behind the scenes. But in some cases, when you call if you call a delegate and it's not got anything subscribed to it, it then throws an error, which really upsets me. Anyway, that's a complicated line of code, but basically we call this method whenever the signal in mob squashed is emitted. That then takes us over here, which will update our score, hopefully. Now, I've said all of that about how that should work. Let's see if it actually does work. Interesting. Interesting. Why are we occasionally emitting it twice? 3 times. It's the way the tutorial does it. VFig. Okay, that wasn't saved. So let's try that again. See if that was just I hadn't saved the issue. Oh. And immediately fluffs it. Good testing. We are still occasionally getting a double count or a triple count. Interesting. I wonder if that means it has spawned 2 in the same place, but that seems unlikely. Okay. So the score is broadly working and the things are broadly working, but there is obviously a bit of an odd thing going on here. So when are we calling squash? This is when we're calling squash. Oh, it might be because if this happens multiple times, we're going to call this multiple times. So if the get slide collision count is more than 1, there is potential that we can call this multiple times. I don't quite know. Yeah, because this doesn't get deleted till the end of the frame, so we could trigger this collision multiple times. So I guess what we want to do just to fix that for now is we'll just do a private is squashed equals false. Oh, Boolean would help. And we'll say if not is squashed, do that. Q3 and is squashed equals true. Oh yes, no, the is mob. Basically, it's saying is it of a type mob, and then also assigning it to the variable mob. As far as I'm aware, so because this the collision.get collider returns a Godot object, which we're then immediately saying like we're testing against type and storing it all in a one line. It's a bit of a. I always think that's quite a fudgy structure, but it is quite a useful structure in code. Right, let's try this again. See if we can avoid those double counts now. Oh, well, we avoided double counts for as long as I stayed alive, at least. Oh, come on. Mob is what we've called one of our scripts. So we've got a script here, or a class called mob, which then means in here we can say like, does this have the type mob, which is this object, I believe. Yeah, it is a bit confusing though, because as you say, it's also we've done a lot of other bits with layers and stuff. I didn't name it that. That's what the tutorial calls it. I wouldn't call them that either. I would call them enemy. Or specifically, I'd probably give them an enemy name. Okay, that does look like that sorted our double count issue though. Which is good. Nice. Nice. It is just now, I've seen it a lot now. It's just a term that people use by default for enemies. I've seen it in a few places. All right. Okay, cool. That's nice. We've already gone a bit above and beyond the tutorial. We fixed that little bug that they don't tell you to fix in the tutorial, at least not yet. We now have the ability to play again after dying. When the player dies, we'll display a message on the screen and wait for input. Head back to the main scene. And select the user interface node. Add a child node colored rectangle. Add node. Color rec. And name it retry. This node fills a rectangle with uniform color and will serve as an overlay to darken the screen. Make it span over the entire viewpoint. You can use the anchor preset. Aha. Is that the right one? Nothing happens. Well, almost nothing. Only the 4 green pins move to the corners of the selection box. It's because the UI nodes all onto the green icon work with anchors and margins relative to the parent's bounding box. Here, the user interface node is a small size. The retry one is limited by it. Select this one. Do this one. Set that to full rec. Come on, let's try that again. That one, full rec. There we go. Perfect. That should also allow us to set the score label to the right place. Select retry. In the inspector, it's color to something both dark and transparent. There we go. 96. 96. Next, add a label as a child. Yeah, okay, cool. And what I want to do here, now I know about the anchor thing, is I want to set it so it's middle top, then also move it down a smidge. So then when we play, hopefully our score should be in the middle top. Yeah, okay, perfect. Now add a label as a child of retry. Label. Give it the text, press enter to retry. Then we can boop that in the middle. What's been going on in chat? Back to the signals thing. The game I've been working on in Godot is an immersive sim with lots of interactions. Making those interactions happen in a specific order within a single frame is vital. The same was true of previous game Prototype, which is a puzzle game. They taught you to avoid signals. I don't know, I still think, like I've obviously made puzzle games and I've still used delicates pretty heftily in puzzle games. It comes back to quite often how you define your signal structures and when signals are emitted. So I don't think it's true to say you just need to avoid signals, but you know, you design your engine and your structures in a way that works for you. Whereas with any making of a game, there's no correct or wrong way to design your game structure, and anyone who says that there is just wrong. It's like how people always say your UI should be totally decoupled from your game. It just isn't. It just isn't. You always get to a stage of any game where you just go, no, stuff's going to be coupled. I just don't care anymore. But you know, I try and avoid that as much as possible. after in Solus I didn't, and it was a complete mess. Alright, now we can head to the code to show and hide the retry node when the player dies and tries again. So we need to go to our main script, and this is where we go back to that override stuff, where we had the ready from before. Now when we're ready, by default we do get node control user interface / retry dot hide. Then when the player gets hit, we show it. So we're just going to grab all of that, put it down there, hush you, and show. So now if we go back here, we get hit. Lovely. So it doesn't, we hide it immediately, and then when we get hit, our retry stuff appears, and all our other things, if them not spawning any more in, works. Cool. Finally, the retry node is visible. We need to listen to the player's input and restart the game if they press enter. To do this, we use the built-in unhandled input callback, which is triggered on any input. Okay. If the player press the predefined UI accept input action and retry is visible, we reload the current scene. Okay, this looks like a code structure I would not use for realsies, but we're going to do it because it's in the tutorial. So where are you wanting this code to go, tutorial? You haven't really said. I'm going to assume it goes in main. Public override void unhandled input. Okay, you need to call the base one. If at event, why is it at event? Doesn't matter. If at event is action pressed, UI accept, and assume we're going to check to make sure the node is visible. So, ugh. Don't like it. Don't like how they've done this code at all. As you would say, as you mentioned earlier, VFig, I would definitely be caching user interface / ready in here if I was doing this for real, because we've now called it way too many times in the code. Get tree dot reload current scene. The function getTree gives us access to the global scene tree object. Okay. Returns the scene tree that contains this node. Okay. Which allows us to reload and restart the current scene. Okay. Yeah, I don't like that code at all. But basically, we've got a special unhandled input thing, which says if we've not consumed that input in anything else, then we can use it. We're then passing this input event, and then we're doing event is action pressed UI accept. And yeah, I don't like any of the way they're doing that. But if we go to project settings and we go back to input map and show the built-in actions, we can see that UI accepts enter, AP enter, and space. I'm also going to add the joypad button back in there, because it's really rubbish if you're using the controller and then you ask people to go back to keyboard. That's just bad design. I am not having. Okay, so there we go. That is now working. Doing that, we press enter and it works. We do that, we press space and it works. We do that and we press A and it works. Get our score is working. Lovely. Our bouncing is working and our reset's working. Very nice. Sometimes built-in actions didn't work for you and you had to make some of your own. Well, that's interesting. I'm not sure why either. They do seem to be working for me. Now at least. Okay. Next thing, we're going to add music. To add music that plays continuously in the background, we're going to use another feature in Godot, Auto Loads. To play audio, all you need to do is add an audio stream player node to your scene and attach an audio file to it. When you start the scene, it can play automatically. However, when you reload the scene, like we do to play again, the audio nodes are also reset, and the music starts back from the beginning. You can use the Auto Load feature to have Godot load a node or scene automatically at the start of the game outside the current scene. You can also use it to create globally accessible objects. I do like globally accessible objects, even though they're a bad plan generally. They are a good fudge, especially in game jams. Create a new scene by doing new scene, new scene. Click on the other node button and create an audio stream player. Interesting. They've got 2D positional and 3D positional as well. Oh no, I use them, but I also think that you have to be really, I've seen they are very easily abused, and I have seen people make their entire game in globals, and they're filthy. In general, if possible, I'd prefer using a singleton in a lot of cases, but I have used both. I just think you have to be careful not to use them too much. A singleton is not quite the same as a global. It's easier to access and more guaranteed you won't copy it and stuff. No, I agree, but I also use singletons very, very rarely if I can avoid it as well. And I appreciate the offer, Jan, but I think it did come with some music, so I think we're all right for now. Right, anyway, let's make this and do music player. It's almost like if you get any developers together in a room, they'll disagree about literally everything because everybody does stuff differently. In the art, apparently we have some music. houseandforestloop.org. Guess we'll put that in there. Turn on autoplay. Okay, and then we save this scene as musicplayer.scene. You're clever enough to save them in the right place. Yeah, that's fine. Don't know why they've told me to save it as a different capitalization this time, but whatever. Okay, we have to register it as an autoload. Head to project settings. Click on the autoload tab. In the path field, you want to enter the path to your scene. Click the folder icon. Okay. Okay. Oh, VFig. That's not true. C++ has caused way more damage to coding than Java ever has. It is literally the worst design language. It is just horrific. All of the pointer stuff, and then all of the smart pointers to fix the pointer stuff, which are even more confusing. Although, to be fair, if we're going down that path, I think we could probably argue that basically every language ever invented has caused horrific damage to programming in general, and would probably be right. Any hoodles, this will now apparently load into any scene I open or play. So if I run the game now, the music will play automatically in any scene. Before we wrap up the lesson, here's a quick look at how it works under the hood. When you run the game, your scene dock changes to give you 2 tabs, remote and local. Okay. We've mentioned this earlier thanks to Portponky. The remote tab allows you to visualize the node tree of your running game. There you'll see the main node and everything the scene contains, and instantiated mobs at the bottom. At the top are the auto-loaded music player and a root node, which is your game's viewport. And that does it for this lesson. In the next part, we'll add animation. Okay, so if I close that, and then I go back here and I run this, go back to remote. Yeah, so it does appear up there. And now we have noise. But that should mean, yeah, the music isn't resetting. Cool. It's actually not system.writeln, it's system.out.println. Just while we're here. So it's actually much longer than that. But most of the development environments, if you type sysout and autocomplete, it will expand it out for you. Oh no, like Java, I like Java for teaching and for learning in because it's very precise, but it is very verbose. And that's why I like C# because it's basically Java but less verbose. Cool. All right, so that's all the music stuff working. So that whole project autoload stuff, that's very similar. In Unity, you can basically define you can specify any game object to not destroy on scene change in the script, which I think's kind of neater. I prefer it, but this also gets around that problem. And I guess it's a way of doing it because, again, they don't have a difference in Godot between game objects and scenes. So this just means you're always enabling it, and it will appear in any of the scenes you open. So if we go to just the player scene, and I think it's F6 to run just this current scene, even though we can't see our player because we don't have a camera, the music's still playing. So if we go to remote, it gets loaded in. All right. Okay, so our final thing is character animation. I think, for completeness, I'm going to go through and do this just because we're nearly there. And yes, it is a long stream, but I'd like to finish this. What about Python? GDScript is heavily based on Python. That's part of the reason I don't like GDScript, because I don't like Python. I like my clearly delineated curly bracket stuff and things being strongly typed. It's a preference thing. I've used Python. It's fine. It's powerful. It's a good language, especially for prototyping. But I get on a lot better with C#. All right. So we're going to start with an introduction to using the animation editor, apparently. The engine comes with tools to author animations in the editor. You can then use the code to play and control them at runtime. If I go and open the player scene, select the player node, I can add an animation player node. Okay. The animation dock. Oh yeah, but that's a really different thing, JFig. Languages should not make white space significance. I find it really dumb, and especially the amount of errors we get in uni when we're teaching it with tabs being changed to spaces and back again when code's transferred. It's really, really frustrating because it confuses players, because it confuses people who are learning, because you're effectively saying this invisible symbol is different to this other invisible symbol, and there's no easy way for you to tell or debug it. And it's just boo. Generally boo. Anyway, animation dock. It features the toolbar and the animation drop-down menu at the top, a track editor in the middle, and a filler, snap, and zoom options. Let's create an animation. Animation new. Name the animation float. Okay, once you've created the animation, the timeline appears with numbers representing the time in seconds. Fine. You want the animation to start playback automatically at the start of the game or switch to loop. To do so, you click the buttons with the A+ icon in the animation toolbar and the looping arrows respectively. Okay, so that's the animation looping. Where's the A+ icon? Oh, there. Okay, that's a slightly more hard to see symbol, but fine. You can also pin the animation editor by clicking the pin icon in the top right. This prevents it from folding when you click on the viewport. Okay. Set the animation duration set to 1.2 seconds. That's that bit. You should see the grey ribbon widen a bit. Okay, cool. It shows you the start and end of your animation, and the vertical blue line is your current time cursor. You can click and drag the slider on the bottom to zoom in. So let's zoom in nice and close. With the animation player node, you can animate most properties on many nodes as you need. Notice the key icon next to the properties in the inspector. Oh yeah, okay. Okay. You can click any of them to create a keyframe, a time, and a value pair for the corresponding property. The keyframe gets inserted where the time cursor is. Oh man, I'm so bad at this with video editing as well. Let's insert our first keys. Here we'll animate both the position and rotation of the character node. Okay, so we select the character. In the inspector, expand the transform section, click the key icon next to position and rotation. For this tutorial, create reset tracks, which is the default choice. Okay, so that's character and rotation. Okay, and we have them, our different key nodes appear down here. This tutorial, you can click and drag the diamond, smooth them in time, move the position key to 0.2 seconds. Oh, okay, so they lock by default, and if you hold control, they don't lock. That's backwards. If holding control, grid snaps elsewhere. It's weird that that's backwards, but it doesn't matter. It's nice there, snapping. Move the time cursor to 0.5 seconds. How do I move the time cursor? Nope. Okay, just by clicking. Clicking and dragging there. Yeah, okay, cool. In the inspector, set the position of the y-axis to 0.65. Rotation on the x-axis to 8. Create a keyframe for both properties. So I guess boop and boop. Now move position keyframe to 0.7 seconds. Yeah, that looks broadly right. What do I think of Godot so far? Well, so far I like it. Generally, I think I like it. I still need to do a lot more work with the 3D part of Godot to see if it will be suitable for what I want to do. So there's lots of stuff I want to play with. Better, basically better, more dramatic lighting. Play with how many point lights it can have, how it deals with global illumination, all that sort of stuff. And also I want to play with the 3D labels. But I like the basic interface and using of it, and I like how snappy it is. I just need to practice more of it to figure out how to use it. As VFig mentioned, I think the debugging is not as strong as, say, Unity. And I think I'll need to practice a bit of that and figure out how the debugging is done, how powerful it is. But genuinely, I think it's good. You asked about curve editors. I did see a curve thingy somewhere. I guess there might be... I wonder if there's a... There's no specific curve thing in there, but I'm sure it will do. I know it took me ages to realise that Unity had animation curves, and then I used them all the time when I discovered them. Alright, a lecture on the principles of animation is beyond the scope of this tutorial. Just note that you don't want to time and space everything evenly. Blah blah blah. Okay, move the time cursor to the end of the animation at 1.2 seconds. Set the Y position. We go back to character. To 0.35, X rotation to -9, and then boop. You can preview the results by clicking the play button. Let's get this to a slightly more useful position. Okay, so we're basically moving it and doing some rotation. That's fine. You see the engine interpolates between your keyframes to produce a continuous animation. At the moment, though, the motion feels very robotic. That's because the default interpolation is linear, causing constant transitions, unlike how living things move in the real world. So that's because I've moved away. When it's not focused, it slows down its interpolation. We can control the animation between keyframes using easing curves. Click and drag around the first two keyframes in a box to select them. Okay. There's the curves. You can edit the properties of both keys simultaneously in the inspector, where you can see the easing property. Click and drag on the curve. Oh no. Pulling it towards the left, this will make it an ease out. That is to say, initial transition fast initially and slow down as the time cursor reaches the next frame. And if we play that, yeah, it looks a little smoother, which is good. Saying put the easing quite high. I guess it was about there-ish. Yep. Apply an ease out to the second keyframe in the rotation stack. Do the opposite for the second position keyframe, dragging it to the right. Animation should look something a bit like that. Yeah, roughly. Let's get it into a slightly better position. It certainly looks a bit nicer. Oh yeah, no, I'm sure if you want to do animations, you shouldn't be doing them directly in Godot for like character animation and movements and stuff. But this will be useful for kind of particle effects and other things, I imagine. Okay, animation update the properties of the animated nodes every frame, overriding initial values. If we directly animated the player node, it would prevent us from moving it in code. This is where the pivot node comes in handy. Even though we animated the character, we can still move and rotate the pivot and change layers on top of the animation in a script. Yeah, and layer changes on top of the animation, so that's nice. If you play the game, the creature will now float. Oh, there we go, yeah. We're moving around and we're doing little bouncy animations, and it all fits with the lighting and everything, so that's good. Nice. Okay, controlling animation in code. We can use the code to control the animation playback based on player's input. Let's change the animation speed when the character's moving. Open the player script. In the physics process, so we've done everything. After the line where we check the direction vector, Yep, okay. In here we can do get node, animation player, animation player. We didn't rename it. Dot speed scale. Then this equals 4. And then else. Set it back to 1. What I'm actually going to do is I'm going to go into the music player. Just whoop, turn that right off. Okay, so this code makes it so that when we move, we run at 4 times the speed. When we don't move, stop moving, we move at 1 times the speed. We mentioned that pivot could layer transitions on top of the animation. We can make the character arc when jumping using the following lines of code. Add it at the end of physics process. Okay. So var pivot equals get node node d pivot. Again, as Vthig mentioned, we should be probably caching these, but that's not what the tutorial is suggesting, so we're not going to do that today. Okay, then we can rotate. New vector 3 ff.pi divided by 6 times by... No, of course it doesn't matter in a game this size, but it's a good idea to do it in general. Especially as we might be spawning lots of things. Right, velocity y divided by jump impulse. Pivot dot rotation dot y comma. That's just going to be pivot dot rotation dot z. Yeah, okay. Semicolon. That should be rotation, I think. Okay, so what we're now doing is we're rotating it based on our y velocity base, which we are affecting up here. So it should sort of rotate upwards and then dip back downwards as we jump. As I say, I've turned the music off because it was annoying me already. Yes, there we go. So what's happening is now, so as we move, we bob quicker, which is cute, and when we stop, we just sort of linger. Oi. And then when we jump, we kind of tilt backwards and then flatten out. We've got to the top of the jump, so it means we kind of look like we're pushing off from our jump, which is quite cute. I actually like how that looks, at least for a little kind of game jam-esque prototype. Okay. Animating the mobs. Here's another nice trick of animations. As long as you use a similar node structure, you can copy them to different scenes. For example, both the mob and player scenes have a pivot and a character node, so we can reuse animations between them. Open the player scene, select the animation player node, and then open the float animation. Yep, we've already got those all open. Next, click on animation, copy. I guess it's been renamed to... Nope. Interesting. Okay, so we open that. There's no longer a copy button. Oh no, this is the first time where the tutorial not being updated has caused me an issue. I guess we probably want to copy tracks instead. So I assume they've basically just made it a bit better. Okay, then open mob scene. Create an animation player node. Yep. Then click animation.paste. I guess we're gonna do this, edit, paste tracks. Hey, there we go. So we've still copied across, just we have to do it slightly differently. Should be them. Yeah, no, that's not quite the same thing, the codec, by the look of it. I think they've kind of maybe moved it into the copy tracks, paste track stuff, but I'm not sure. Anyway, we've got it copied across now, so that's good enough for me. We want to auto and loop again. So now the monsters will play the float animation. So if you now go and in here, save everything. Yeah, there we go. Yeah, so that's copied across there. The same sort of bobby floaty motion. I actually think it looks better for the enemies because, well, because they're a bit longer than we are. We can change the playback speed based on the creature's random speed. Open the mob script again. At the end of the initialize function, the following line. Get node, animation player, animation player dot speed scale equals random speed. I assume we probably want to modify that. Random speed divided by min speed. Okay, now let's see if that works. Kind of hard to tell with the difference in speed not being very dramatic. So let's increase the difference in speed. So we can get really slow mobs. Then try and actually avoid getting hit by them. Yeah, I think those animations are playing at different speeds. No, actually, now I'm not sure if they are. It's kind of hard to tell, honestly. Oh, okay. Yeah, now they're definitely playing at different speeds. Must have just not quite saved stuff and updated stuff. That's fine. Let's put that back to 10. Alright, with that, you finished coding your first complete 3D game. Meh. So, in the next part, we'll quickly recap what you've learned and give you some links to keep learning more. Alright, so I'm just going to very quickly go through the final next thing. The slower they move, the faster they bounce. That makes sense. Alright. So, in this series we went over a wide range of techniques and editor features. You've witnessed how intuitive Godot's scene system can be, and learned a few tricks to apply in your projects. Just scratch the surface, blah 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 blah. Yeah, and that just talks about the manuals and where to go next. Cool. So, yeah, there we go. We have finished the Your First 3D Game tutorial in Godot. We have a game that kind of broadly works. Needs a lot of tuning on the collisions because they're feeling a little off at the moment. But I can play this on a controller and it works fine. I can play it on the keyboard and it works fine. Either using the arrow keys or WASD, which is nice. It actually feels a lot nicer playing it on a controller because of the direction movement, but that's by the by. Yeah, we've also fixed a couple of bugs that the tutorial had along the way, which is nice. I think that was one of the big things they've been talking about with Godot 4.2. Is that the physics is meant to be better? I think they've been doing a lot of updates to improve the physics JFig. But it's kind of okay because, broadly speaking, I don't tend to do real-time physics-based games anyway. So actually I care more about stuff like, stuff like the lighting and being able to raycast into the scene to do sort of node-based 3D games. Oh, that's a shame. Poor Bonky. That is the risk of open sourcey stuff, is that you're at the whims of it. I did see something that they talked about them working on improving the physics. It might be that they've just got an influx of money from game companies after the event. So it might be something that they said they were going to look at improving. Now they can more directly hire people. Alright, something I now want to try to tweak things a little before I wrap up. I want this directional light to be a lot less bright. First off. Lovely. Then I want every mob to have a light of its own to see how that looks. Let's put it in the pivot. I think Omni lights are basically point lights, so if I now play that, does that mean all of the mobs should have a little... Interesting. There is obviously some light interaction, but it's not interacting with the floor. I mean, yes. Incoming things. That's it. I'm not sure, VFig. I'm going to explore that in a sec. But yeah, absolutely. If we move them above them, let's see what happens. Okay, yeah, that was definitely part of the problem. Also, we've not enabled shadows. Here's another problem. There we go. That gives them some nice dramatic shadowing. Okay, cool. Oh, that's when we're using... That's for global illumination. We're not dealing with global illumination yet. What's negative? What? If true, the light effect is reverse darkening areas and casting bright shadows. That's fun. But let's give them a nice orangey light. A bit more orangey. Let's give them a bit more energy as well. Okay, I think what I wanted to do is give them a bigger range. Size of the light in Godot units only available for OmniLight 3Ds. Increasing this value will make the light fade out slower. Shadows are blurrier. This can be used to simulate area lights to an extent. That's not what I want. Ah, thank you. Yeah, again, slightly confusing that things live in slightly different areas, but, that's on me. Not knowing the editor very well. So increase that. Oh, I like that you can fiddle with the attenuation curve on the spotlights. That's really nice. So Well, if I fiddle with... If I do that live, will that change live? I think it did change live, yeah. But I'm not 100% sure. No, it didn't. Okay. Okay. So first of all, this is making it clear I need to spawn them slightly further out. That is really nice that you can change the attenuation curve on the lights. I like that. And what I might do is get to our path, our spawn path. Might just hoik these all out a little bit, because now our lights are making it obvious that they're spawning in the scene. Probably needs to be a bit further out on that side as well. All right, and yeah, that's a bit better that we're not seeing the lights, although they're now probably vanishing a bit too soon. But a quick hacky fudge we can do for that is we can just make this a lot bigger. So they have to be further off. Oh, they have to be further off the world before they're counted as invisible. And I'm absolutely sure this is not something you should do. Like, I'm sure that's not how you're supposed to do it, but it does seem to work. So I'm going to keep it. I mean, that already looks quite a bit more interesting visually than it did before, and it seems to be handling the lots of spotlights really quite happily. So there's obviously, it must be doing, I assume it must be doing forward rendering by default. Oh yeah, it is. Forward plus. I was changing the shape, size and scaling it there. Yeah, probably. I always think that's a problem with this stuff, is I think it's really a bad idea to have this stuff linked together, like the scale and the size of things. I always think that's a bad plan in anything. Because of course people are going to do that. Let's just make those 10 and 10, -5, -5. See if that works. A good spot, thank you. Alright, so that seems to be all working happily. And then I guess... is there something else I wanted to fiddle with? It's all nice, and then that I assume is for your different layers, so you can say what it's going to work with. Ah yes, I wanted to press the negative light and see what that looked like. Oh wow. That's certainly a visual style. Huh. Oh, that is very weird. I kind of like it though. So if we do that, but then we make the directional light have the same energy as before. Come on, scene. $10 mega bright. Oh, probably too bright. How about 2? That is so weird having negative shadows. So, that is really odd. That is, yeah, weird. But I do kind of like how all the... no, I will not do that, Port Ponky. All right. Well, that's entertained me with the negative light. My chat's arguing about how best to update the lighting. Cool. The other thing I did see that I really like that it has by default is it has projectors in the lights. They're a bit fiddly to do for 3D lights because you need a cube projector. But for spotlights, you can just put an image in and it will then do like proper kind of gel projectors in front of a spotlight. So you can actually have like projectors, like overhead projectors in your game really easily. And I think that's a really nice thing. Oh, that is useful to know, VFig. Editing and remote gets thrown away when you stop the game. Nice. Yeah, and at some point in the future, I'll go and have a try with kind of the volumetric lighting and the global illumination, because I really want to have a try and a play with that. I might go back to not negative light, because it's very strange. I don't think we have... Environment's volumetric fog. I wonder if that is somewhere. Where would that live? Yeah, I have no idea where that would live, but that would be fun, putting volumetric fog into this as well. I'm going to give that an energy of 5. Fog lives in your world environment node in your main scene if you have one. Ah, good to know. In which case, let's go put one in quickly for the giggles. Just make sure that's all looking broadly as I like. Nice. All good. My 3070 really being taxed by this amount of spotlights, clearly. What happens if you put energy below 0? I don't know. Are we allowed to put energy below 0? No. We're not allowed to put energy below 0. World environment. So let's do a new environment. Open this. Oh, hello. Oh, tone mapping. Hello. Glow, hello. This is how we get to all our volumetric lighting and all of our global illumination, I guess. Volumetric fog. On. Okay, I don't think that made much of a difference, but that's maybe... Let's just crank that right up. Absolutely hasn't made... Oh no, to be fair, as they're going off the top of the camera, you can see them starting to get a bit more fogged out. No, yeah, no, I know, I'm just playing. Let me play. Just for that, we're going to crank the density up to a ridiculous amount. Maybe I've cranked that up too much. Look, I'm going to change it in here, save the scene and hot swap it. Are you happy? Oh, there we are. Yeah, they definitely they definitely vanish more into the fog if you go up the screen now. Yeah, we're not exactly using the correct type of lights to really take advantage of environmental fog either. But I saw somebody say enable glow. Absolutely, let's enable glow. Let's maybe disable volumetric fog because it's not adding much. Not entirely convinced glow did much either. Ah, bloom, you say? Whoop. That's the option I need to make it a proper amicable animal game. Bloom all of the things. Intensity up. Strength up. It's almost like just cranking them all up to max wasn't the right thing to do. Fine. The HDR threshold, if we move that down, that should probably fiddle with things. Should make it easier for things to max out and start blooming. Ha! Change the blend mode. Yeah, good idea. Oh, there we go. Now that's starting to look more like an amicable animal game. Unnecessary amounts of bloom. Now I want to turn the intensity up and see what happens. Oh boy. That is nice. I mean, it's not nice, it's horrible in many ways, but I am very okay with this. Okay, now that means what I really, really want to do. Yeah, okay. What I really want to do is in the mob, get node OmniLight 3D, OmniLight 3D, dot light color equals. What are you expecting this in? Color. Is your new color? Perfect. dd.random range 0 255 color.fromHS. Okay, I'll try that. Oh yeah, so then we can define the typically. Okay, and then we can do, if it's that way, we can do gd.randf for hue. Obviously, max saturation, max value, max alpha. Yeah. Clearly there's a bug down here. Object not set. It's because it's in the pivot, so that needs to be pivot slash that. That pleases me more than it should. It's so bright. So unnecessarily bright. It is very, very bloomy disco. giving away the secrets of basically how all of my game's visual styles are. It's do lighting, then make it high def lighting, so I can specifically tune what's going to glow and what's going to cause bloom, and then I make stuff glow whenever it needs to look like a monitor or something. Goodness, I probably would maybe even turn this down a little bit. If I go to here, turn the intensity down to 1, see how that looks. Oh man, when they overlap, boy do they get bright. Can you make the materials emit light too? I haven't seen. I think you probably could if we go and grab one of these cylinders. Go into the material. Yeah, there's emission. There is an emission property. So yeah, apparently. I don't know how it works in Godot as well, but sometimes you can use emissive textures to just make things look full bright, even if they don't contribute to the scene around them, which can be helpful. How do I make the player emissive? Where is the actual character model? That should be the character model. Yeah, so I can't obviously change it. Is it up there? Yeah, it was automatically imported, so it can't be modified. So I'm probably not going to fiddle with that today. Alright. I will take your word for it, chat. So that's the mesh. What I'd like to do is this one. Yeah, it's still, all of this still seems set externally in a way that I can't faff with it though. Anyway, I'm going to ignore that for now, just because I've been streaming for 4.5 hours. It's definitely getting time when I need to go and have dinner. Oh, now I feel bad because you've told me how to do it. Fine. Fine. Clapperboard, new inherited, in here, open that. You want the surface material override, where's that? Ah, down there. Oh, and then I make my own material. Okay, so that's the same as when you're doing it in Unity, yeah. So do new standard material in here. Make that emissive. Make that all of the Fs. That's probably fine. Thank you. All of the energy. Right, so missing in the scene. Interesting. Yeah, emissive should feed into bloom as well. That's often how I tend to fiddle with it in Unity. So I need to save this as I guess player 2. And if I go back into player, can Can I now just put this into pivot? And can I copy its entire transform? Maybe. I'm sure there's a way to do them all at once. Let's just do them like that. Okay, now we make that one go away. Let's see how this looks. Well, that is certainly an emissive eyeball now. Man, that looks not great, honestly, because for some reason we're missing in quite a square way. Okay. Ah, yeah, I see what you mean. I guess there's no easy way to change that. Yeah, what I will do just quickly, I want to turn that emiss energy multiplier down a little bit. Oh, okay. That's a nice way to do it. We're all learning. It didn't work. It didn't work, VFig. No, it just deleted the character animation. But we did learn that we can just copy it from in here. So let's copy the tracks from in here. And never trust again. Why are you not? Why are you not happy? Ah, I didn't click those buttons. Thank you. Nope, still not still not happy. I pasted them in the reset animation. Oh, yeah, that sounds like... Yeah, that sounds like what I did wrong. How do I just delete all of this now? Bin icons. Cool. Select float. Paste the tracks in float first off. Do you need to set to character? Yeah, it is set to character because we renamed that. Autoplay and loop is on. Hey, there we go. Problem solved. After some fiddling. Man, that emissive eye, it's not great. Maybe knock that back down a little bit. Operator, put multiplier on for the giggles, see what that does. Oh, apparently not make it stop emissing. There we go, that's a bit more in line. That our eye now actually looks like it's emissing all the time. And admittedly is a bit overwhelmed by everything else. Boop. Boop. move this up there, and let's go back to like the main scene so we have some stuff in the background as well. Nice. Well then, I think I am probably done for today, because we have gone through the entire Make Your First 3D Game tutorial, we have fixed some bugs in it, we have massively blown out the lighting in true Amicable Animal style. So bloomy. And we've even put an emissive texture on our eyeball. So we have gone a bit off the tutorial and off the beaten track with this, which is always good for learning. And it's been interesting from my perspective to see how the 3D systems work and to play around with some of the systems in it. I like that it defaults to forward rendering because Unity, if you're using the built-in renderer, still defaults to kind of traditional rendering where you have a limit on spotlights, which is a bit of an issue in CRT7. And then its forward rendering path, it does not do very good anti-aliasing or anything on it. So yeah, I think Godot's got a nicer default for that. I will be quite interested at some point to play around with the global illumination options and set up a nice little globally illuminated scene. That will be at another time, I think. No, the forward rendering won't be by default supported on mobiles, but I do not targeting mobiles with my games, so I am fine with that. It also seems to compile to Vulkan by default, which is also nice for speed on PC in particular. Yeah, I mean we've got dynamic lighting, we've got dynamic shadows in. Nice, frankly. That has been quite a productive and educational 4.5 hours for me. Thank you very much to all the people in the chat who gave me some hints and tips when I got stuck and stopped me from being stuck for too long. I understand that is, you know, partially selfishly motivated because you don't want me to be stuck for too long as well, but it is very useful to be doing this with people who know what's going on, who can point at common mistakes. Because that's the position I'm in with Unity, is I kind of know the most common mess-ups by this point and can help other people. But being new to the Godot engine and environment, it's really useful to have people around to help out with that. So appreciated. Yeah, general final vibes from this is that I thought the Godot was really good for 2D when I did the 2D thing. I wasn't sure how good Godot would be for 3D. I think for basic 3D kind of prototypes and stuff, it's obviously absolutely fine. And I can see why it's getting used a lot more at game jams. Partly because of the lightweightness of it as well, means it's really quick to get stuff up and running at game jams, which is always nice. As I say, I want to explore a bit more, play around a little more with the bloom settings and the global illumination stuff, and see how it is a bit more at the kind of high end or the stylized end. Because there's not so many 3D Godot games I've seen out there that go for kind of quite stylized or heavily lit styles yet. So I want to play a little bit more around with that to get my head around it at some point. But yeah, up until now, I'm pretty impressed. 3D stuff's been quite good. There are a lot of nice primitives built in for prototyping between cubes and cylinders and toruses and stuff. And yeah, I have broadly been quite impressed by Godot in 3D. It's certainly a little bit further along the path into 3D than I was expecting it to be, without any real knowledge or expectation. And the tutorial stuff, if you want to learn Godot, Your First 2D Game and Your First 3D Game are actually, I think, really good tutorials to give you a really nice idea of the basics and the overview of the workflow. It might teach you some slightly bad practices, but most tutorials do. And I think it's nice that they're showing you a bunch of different ways to do things through the tutorials, like through the signals or through the scene graph. it's just, yeah, generally quite nice. Yes, and the built-in documentation that pops up in here, that's really nice. We didn't really use it today, but yes, the fact that you have all of your references and you can access it in the editor is real nice. As my chat has said, a couple of different people in there. That is, yeah, one of the really nice features. It's also part of the reason I suspect in the longer term we'll be moving to Godot for teaching purposes, because actually finding the documentation and using the documentation is one thing that new coders and students really struggle with. So having it built in, good, very nice. Yeah, I don't know. Well, let's see. That's not control. I don't think it will access it from in here, but there were definitely bits around the interface where you could. So I think if I go to like add a child node, there was ways of getting to it somewhere. Oh, you can favorite nodes as well. That's nice. But yes, this wasn't supposed to be a full introduction into the interface. This is very much me learning in front of people as we go. So I'm very happy with where we've ended up, and I'm very happy we've managed to customize the tutorial thing to be a little bit more in my wheelhouse with unnecessarily bright, bloomy colours. Just need to swap that music for some sort of synthwave from Solas, and we'll be pretty much there with an intro to my style, especially in game jam situations. But for now, I think I'm going to go find some dinner. It's nearly 7 o'clock over here. But hopefully you've had fun watching this, and if you are new to Unity as you're watching this, it's given you a good idea some of what it can do and some of the extra random stuff that we have gone off pieced for and found. So yeah, perhaps I will do some more dev Godot learning stuff in future if people are up for that. But for now, thanks very much for watching. Thanks to everybody in the chat. Have an excellent rest of your day whenever you're watching this. And if you are looking at switching over to Godot from Unity, I hope this has been a bit of a help. Thanks very much, and goodbye.